Welcome Valarmati ma'am and Premlata ma'am.
Yeah, thank you ma'am.
Vijay, நீங்க 10 o'clock session start பண்ணலாம். வெனிலா join பண்ணிக்குவாங்க.
Good morning, doctor. Thank you.
வாங்க.
Good morning. Now actually we are going live. Let us start the session in a minute.
Vijay Mohan sir has joined.
Yeah, I can see that.
Morning sir.
Morning. All set?
Yes sir.
Yeah.
Yes sir. It's going live, sir.
Okay. Right, boss. Right. All the best.
Thank you, sir.
Thank you sir.
Good morning, one and all. I welcome you all to this live webinar session on Biostatistics and Research Methodology Part 3. On behalf of IAOHNS, I would like to place my sincere thanks to this entire team who has joined for this live webinar discussion on this Sunday morning. This program is going to be our last program of IAOHNS of this year 2020. Next year we are coming up with more interesting topics. In today's program, we are going to have few lectures followed by a panel discussion with different research study scenarios raised by our postgraduates. Few queries were similar, so we have chosen few queries for discussion. So I would like the participants and postgraduates to send questions and their queries on their research topic to iaohns@gmail.com email, and it will be answered shortly. So from IAOHNS, we are planning to start a research methodology committee, and it will be narrated by Professor Mohan Kameshwan sir at the end of this session. Dear participants, please have a good internet connection as it is relayed in HD quality. Be closer to Wi-Fi router if you are using Wi-Fi connection. If there is any question, type in the box below the video, and you can give feedback about the relogin issue when they refresh the page. So you can refresh or reload the web page if there is any delay. After all the lectures, we will have the discussion and assessment, which will be uploaded in the website as a link to Google form. Please fill it up. Kindly refresh the page to get the link. As this program is Tamil Nadu Medical Council accredited with 4 credit hours, the participants who have attended all 3 series of the program will get the credit point after making a payment of ₹100. The bank account details will be shared with those who have attended all 3 sessions, and it will be verified by the Tamil Nadu Medical Council before sending the account details. So those who have registered for the credit point via email, they will get the bank details by 30th January for making the payment. Let's get into the topic. I'm sure this team doesn't need any much introduction, and I would like to request Dr. Sendil Vadivu to take over the session.
Thank you Vijay. Small correction. The mail account details will be sent on 30th December.
Sorry.
It's not 30th January, na?
Yeah, 30th December.
And those who want the attendance certificate for part 2, that can be downloaded as like the part 1 attendance certificate similarly. Illa Vijay?
Yes.
Okay, fine. And now I would like to welcome Valarmati ma'am once again for this session. And ma'am, over to you, ma'am.
Yes, ma'am. Is my slide visible, ma'am?
Yes, ma'am.
Yeah. Very good morning to you all. We are going to have a session on choosing an appropriate statistical test. You might have been done a study you might have seen some evidence in your clinical practice and you wanted to test that whether it is significantly evident. You know that it is a very good clinical outcome, and if you are going to give that treatment, definitely it is going to work out. So you have been watching a past 1 month or 2 months, and you wanted to prove evidently that the research is true. So in that aspect, the statistical test plays a major role in order to make your study evident. So remember, you are making evidence with the help of statistical test. So if your experiment needs statistics, definitely you have done a better experiment. This is by Ernest Rutherford. Yeah, directly further delaying and directly jumping into testing of hypothesis. What is testing of hypothesis? In your clinical practice, you have found some treatment is working out. So you will be framing a research question as discussed in the protocol, and you will be framing a hypothesis. How you can frame the hypothesis? Because a formal method to make statistical inferences from the data. A research question should be converted as a hypothesis when definitely you are going to compare the groups and you wanted to say that one group is better than the other. In that case, definitely a formal method to make statistical inferences of a data, you need to frame an hypothesis. If the answers, the question, whatever the research question you are having in your mind and which you have framed in your protocol, whether the results, whatever the results you are obtaining at the end of the study, whether it is statistically significant or not, that is what you wanted to find out, because you make that evident for your research. See, there are two hypotheses generally framed. One is null hypothesis and another one is research hypothesis. Whenever I say null hypothesis, null means what? It's a zero. I'm going to make it zero, and always it should be a universal statement where everybody could accept that. For example, if I'm going to tell always in the research methodology class, always female women lecturers are better than the men lecturers. If I'm going to tell, definitely everyone will, at least if you don't ask me, at least you will be in your mind thinking that how she can tell like that. So every time you need to have the null hypothesis where you need not get into your argumentative statement. Whatever the statement, if you are going to frame, it should not be debatable. So it should be acceptable by all. And our major goal is to nullify the hypothesis. So always make that there is no difference between the groups. If suppose you are going to tell there is no difference, then it means that both are equal. So when both the groups are equal or both the groups are same, like that you have to keep the null hypothesis. And similarly, there should not be no association, no relationship, like that you need to keep the null hypothesis. Then you can frame a research hypothesis based on that is the alternate hypothesis to the null hypothesis. Why we need to have a research hypothesis? That is the thing which I have found out and which I wanted to do a study and make it evident. So I am framing a research hypothesis to make evident about my treatment or some treatment or some drug effectiveness, whatever that you wanted to keep it in your protocol that you are going to prove. So always there will be a difference. There will be a difference, or there will be drug A is better than drug B, or drug C is better than drug A. Like that you are going to prove that. In that case, there is a difference between the groups. You can say if there is a difference, then it is going to become not equal. Why I'm coining equal and not equal, you will be knowing in future slides why I'm telling like equal and not equal. So remember that always null hypothesis says that both are equal and research hypothesis says that they are not equal. Okay, and also you can also consider there is no difference, and which usually people used to tell there is no difference between the groups and there is a difference between the groups. And here what is the role null hypothesis playing? Always people think that why we need to have two hypotheses, one is null and the other one is research hypothesis. See, for example, already I have discussed the same example with you on the other day of sample size class. Now I'm recalling that, that is, suppose I'm going to keep null hypothesis, all crows are black. Everyone will accept that all crows are black. What is my research hypothesis? All crows are not black. So what I do is I will take you to a place where I could show in Chennai there are white crows, and I could show at least one white crow in my place. Then definitely what happens to my null hypothesis? It is nullified. There is some evidence for my research hypothesis that there are white crows also. So in that case, I am nullifying my hypothesis. And also, even if one crow is evident that the null hypothesis is not true. So there is some evidence for my alternate hypothesis, even though there is no significant result, but there is some evidence for my research hypothesis. So always I try to reject or do not reject null hypothesis, because this scenario, in this minute, I could not prove some treatment effectiveness, which I found out through my clinical practice because of sample size or because of some other reasons, or the study design which I have framed might not prove that, or sometimes there might not be much cases for that to make it evident. So in that case, we can always say reject null hypothesis. If we are rejecting null hypothesis, then we are evident to have my research hypothesis to be true. There is evidence for my research hypothesis to be true. If I'm going to say do not reject hypothesis, today I am not proving my research hypothesis, or there is no evidence for my research hypothesis. In future, there will be some evidence with some structure or a systematic way. If I could done the research hypothesis with more number of samples, I could definitely make it evidence. So you need to find out evidence. If your study is evident, then it is necessarily to prove with your null hypothesis. So some of the things which we need to have while considering a group comparison is confidence interval. A confidence interval is nothing but an interval in which the true value lies. Suppose you are comparing a drug A with drug B, and there is a difference in the drug B, then a difference which you are going to coin will lie middle, and there will be a lower and upper limit. The value which you are finding, the difference which you are finding is going to be the true value for the drug effectiveness, and the lower limit and the upper limit will be there. Why I need confidence interval? It is nothing but the probability that the procedure provides an interval that covers the population mean. And also it is an alternate way of expressing statistical significance. I will let you know how it does. The statistical precision. What is statistical precision? When I give a confidence interval, I tell the stability of my estimate, and it is always expressed using the confidence interval. And also I would like to make a point that if your confidence interval is narrower, then you're more likely the results is going to be true. And if it is wider, it is might be due to sample size. So I bring an example here about confidence interval. See, for example, I'm doing a study A with 100 people, and average systolic blood pressure. I'm going to measure systolic blood pressure, and I found out that average systolic blood pressure before the treatment is 170 mmHg, and after the treatment is after I intervene something, and I could find that 150 mmHg. What is the reduced rate? That is the difference between 170 and 150 is 20 mmg. So I could reduce 20 mmg out of my intervention. And I could see the confidence interval says that lower limit is 15 mmHg and upper limit is 25 mmHg, where 20 lies between 15 and 25. So now I'm going to say that I'm going to conclude my significant result as true effect of the treatment is to lower the BP by 15 to 25 mmHg. So there is an evidence for the true effect of the treatment that my intervention or my treatment reduces by by 20 mmg. And I have also conducted the similar time a study B with some other intervention, n equal to 50, and average systolic blood pressure. Before treatment, it was 170 mmHg, and after treatment, it was 150 mmHg. Here, the reduced rate is 20 mmHg. And here also, I'm trying to find out 95% confidence interval, that is lower limit is minus 5 mmHg and upper limit is 25 mmHg. And here what I conclude is you can really see no true change in BP and that the drug was actually ineffective. Just have a think why I am telling here, here also 20 mmg reduction rate, and in the study B also my reduction rate is 20 mmHg. So you might think why two different interpretations for the same reduction rate. So it decides the confidence interval. Based on the confidence interval only, we are deciding this. For example, the true effect of treatment is to lower the BP by 15 to 25 mmg. And I found that 20 mmg is within the interval, that is the true value, but there is no zero in it. Whereas in the study B, when I see the lower limit minus 5 to 25, there is a wider interval. And also, there is a negative value where the interval contains a zero in it. So I say that no true changes in a BP. So even your not only your p-value says about the significance, also your confidence interval says about the significant. So the study B might be due to sample size or might be due to the treatment which given should have more number of people to detect the true effect. For that reason only I say in both the cases reduced rate 20 mmHg. So I need to say reject the hypothesis or do not reject the hypothesis. Might be the study B which has some intervention can work out in the later stage. So remember well, if the confidence interval contains zero in it, then there is no true change or there is no true effect of your treatment. Next, p-value. The p-value and confidence interval are inversely proportional. See, when I say 95% confidence interval, that means 5% I have a p-value. P-value gives the probability of any observed difference having happened by chance. By chance alone, my result is true. So p equal to 0.05 means that the probability of the difference having happened by chance, that is, I can make 1 in 20 an error. See, suppose I do a study with 20 people and I see that one person it doesn't work, then it has happened by a chance of 0.05. That is the error. So one person might not improve upon for so many reasons, but since we are doing with a homogeneous group, 19 people have got well out of the treatment. So I conclude that there is a true evidence because P is less than 0.05. So the lower the P value, the less likely it is that the difference happened by chance, and so the higher the significance of the finding. So whenever the p-value is lower, then you have the higher significance of the finding. And sometimes when we put it in the software for analysis, the p-value might result with a 3 decimal like 0.000. If it is like that, it is not that you have proved 100% your treatment. It is not that, because in the real world scenario, you can prove 100%. The maximum we prove, that is 95%, we prove that the treatment works. Definitely the treatment will work for all the others. So p-value here we are not trying to prove. See, if there is a 0.000, you just write in the result p is less than 0.05, because after the 10th decimal or 9th decimal, or it might be in the 20th decimal, you might have a number. So that is the thing. So you should not, if you get a p-value equal to 0.000, then just put it in the article p is less than 0.05. Type 1 and type 2 error. See, type 1 and type 2 error are H0 is true and we are not rejecting the H0, then it is a correct decision. And here the H0 is true, whereas we are rejecting the H0, then it is type 1 error. H0 false and we are not rejecting the H0, then it is a type 2 error. Whereas H0 is false also, we are rejecting the H0, then it is a correct decision. So already we have discussed type 1 error is nothing but your false positives, and type 2 error is a false negative. See, suppose I say type 1 error is nothing but an incorrect rejection of a true null hypothesis. It is a false positive of a patient to have a disease when in fact the patient doesn't have the disease. So remember that type 1 error is nothing but incorrect rejection of true null hypothesis. It is a false positive of a patient. Okay. And what is type 2 error then? Type 2 error is nothing but fail to reject a false null hypothesis. It is a false negative. Okay. See, for example, if you have a blood test failing to detect the disease it was designed to detect in a patient who really has the disease. A person has a disease, but the blood test says the person doesn't have the disease. So it is a type 2 error. And moreover, people are often debating about type 1 error and type 2 error, which is a serious error. For example, which I have discussed today, both the examples which I have discussed today, I say that type 2 error is more serious because the people who are having the disease, I am letting them out. For example, in a COVID case, if there is a false negative, what will happen? It will create a serious problem. The disease might be transmitted to so many people. So the false negative should be reduced in order to have a good study. So always type 2 error is serious in my angle, but people are often debating on that aspect. So one author says that it depends on what situation, under what research you are practicing it. It is a health setup, then you need to consider about the disease. If it is any other marketing thing, and you need to know which is serious, depends on your research. Okay, for in my angle, type 2 error is serious error. And we have some values 0.05, 0.01 and 0.01. These are the values which we will be incorporating when we have 5% in the calculation. Power of the test. Power is the probability equal to 1 minus beta. We say if it is in a decimal point of correctly rejecting. If I am going to correctly reject my H0, then I will have a good power in my study. That is, when I am correctly rejecting H0, when it is really false, then I say the power of the study is 100 minus beta. And beta is nothing but your type 2 error. That is, acceptable risk of type 2 error is often set at 1 in 5. I can make an error among 5 people. One can need not be make evident for my study. That is a probability of 0.2. That is 20%. So always people, when calculating sample size, they keep the power as 80% or 90%, where it is inversely proportional to your type 2 error is 0.02. So error should be very minimum in order to make your evidence better. See, the conventionally uncontroversial value for adequate statistical power is therefore set at 0.2. In a health setup, always we can have 0.2, that is 0.80%. Below the power, below 80% power, you need not do a study at all, because more error, more of type 2 error, 20% or 30%, if it is going to be increasing, then it is waste of time to do the study. So always remember to have 80% or 90% in your sample size calculation, though, so that at the end of the study, you will be landing up between 80% and 90%. So when I keep 80% or 90%, chance of an effect that really exists showing up as a significant finding. See, normality. On the first class, I have discussed about normality. Whenever your standard deviation is greater than half of mean, it is a non-normal data, a skewed data. And whenever the standard deviation is less than half of mean, then the data is normal. Here, why we need to have normality? If the data is normally distributed, I will go for a test called parametric test. If the data is not normally distributed, then I will go to a non-parametric test. See here that how you can check for normality, whether if it is if your standard deviation is less than half of mean, then you can go for a parametric test. If it is not normal, then you can go for a non-parametric test. What is parametric test? See, suppose the first test I would like to say is about t-test, used for continuous data. The purpose is to determine whether there is a difference between the means, So you will be having a continuous outcome in your data, that is your dependent variable or a measurable variable which you are having. You wanted to find whether there is a difference between two groups. For example, I have a set of men, and I have a set of women. So I can say these are two groups or a two nominal variable where a group of person with women and a group of with the men. So men and women are in my study, and what I am planning to do is I'm going to measure them the BP, blood pressure value for both the groups, and I would like to compare whether there is any significant difference in the mean blood pressure value among men and women. So in that case, I need to have independent t-test. So I have a continuous measurement that is systolic blood pressure or diastolic blood pressure. I'm comparing with two groups, women and men. Then I need to use an independent t-test. So next is the paired t-test, used for continuous data when each subject serves as a own control, like before and after a drug A versus drug B in the same patients. So suppose I am going to have a study like the person who are having a knee pain, I'm going to have a VAS score. Okay, the people who are having a knee pain, I'm going to take the scores of those between 0 to 10 VAS numeric pain distress scale, and I will be evaluating that. And I will give some intervention like exercise or something to these people, and I will try to measure the same VAS score after a month time. And if I could find out these persons has improved, in this case, I need to use paired t-test. Why? Because the same persons who have the knee pain, I'm taking them into a group and I'm trying to give some intervention to those people, and I'm trying to find out the outcome of the same people. So it is like a before and after test, or I can say it is a dependent sample, or I can also say the people who are having the pain will be the control. They themselves will be the control, self control. That is because after 1 month I'm going to measure those people's VAS scale. So in that case I can go for a paired t-test. See, suppose I have a stress, okay? I have measured the stress among men and women, and I have recorded the stress. And I am planning to do a randomized control trial, and I am going to randomize these people into groups. These are either men or women, or equally men and women, put it in the 3 groups. So for the first group, what I'm trying to give is just, I'm going to ask them to listen to the music. And the second group, I'm just going to make them to meditate for a while, for some time daily in the morning, or like that I'm going to give. And for the third person, just I'm going to ask them to practice some aerobic dance or something. Here in this example, I'm going to ask them to do some aerobic exercises. So I measure stress, and I know people are having stress, and I'm having 3 experimental group. One they will be listening to the music, other they will be meditating, and the third one will be doing aerobic exercise. So at the end, I need to compare whether my experimental group has some effect of see whether yoga is better than music and aerobics, or aerobics is better than the other. Like that, I wanted to find. So here my groups are three. One is music group, the other one is meditation group, the third one is the aerobic group. In that case, what I will be doing, I will be using ANOVA. I will try to find whether my mean stress score has a difference between these groups. For that reason, I will be using analysis of variance. So when we are having continuous outcome, like in the case what I have told, systolic blood pressure or the vast pain score or the stress scores, all those are continuous measure where I am going to have a continuous. If you're going to have a continuous measure and you are going to put it in your results, then that time you can go for a box plot, wherein the box plot, say this is the box plot, which has minimum, lower extreme is nothing but the minimum value of your data set, and lower quartile, that is the rectangle's lower part is 25th percentile, and the median is your 50th percentile, and the upper quartile is nothing but 75th percentile, and maximum is the upper extreme. So these are the 5 measures which we can see in a box plot. So whenever we do a study, like normally distributed with independent t-test, paired t-test or ANOVA, you can go for a box whiskers plot to depict that. See, for example, if the both the plots for male and female are going to be similar, if you could see here, no, it looks similar. So if it is going to be similar, then there is no difference between the two groups. That is what we are trying to tell with the box whisker plot. See, even significant value is proved, and as well as the box whisker plot shows that there is no difference. Here, whenever the box whisker plot overlaps one with the other, then we can say there is a slight differences. There might be, it is clinically significant, but it is not entirely significant difference because it is overlapping. Another example, I can say that I have different doses given to 3 groups, 0.5, 1, and 2. Some dosage I have given, and in that case, I could find that the pink, green, and blue are the 3 groups wherein I have put the box whisker plot. See, I can say from the plot, there is a difference between the pink, whereas there is no significant difference between green and pink and green and blue. But there is a significant difference between pink and blue. Why? Because green and pink is overlapping, green and blue is overlapping, whereas pink and blue is not overlapping. It is far away from the box. So I can easily conclude that there is a significant difference on seeing visually the graph. See, suppose you have so many outliers in your box plot. What box plot does is it does not take in the extreme values when we do a box plot. It does not take the extreme values. See, for example, when I do a dengue cases, if I'm going to see the platelets, what happens? There will be sudden fall in the platelet. Many people will having a reduced platelet, and after inducing platelets, there will be sudden rise in the platelet. If I'm not wrong with the example, I'm saying, so if there is a sudden change and there will be some fluctuations in that results, in that case, we cannot go for a box plot because there will be so many extreme values while we doing the study. If you know that there are so many extreme values, that the outliers are there in your study, then don't go for box whisker plot. Try to do an error bar plot because it gives the correct interpretation. And also in the first class, I am told about the error bar plot. Error bar plot is nothing but % confidence interval plot. Here, I have rated the pulse rate simply for resting. While resting, the pulse rate for people who participate in sport, and I have made an error bar plot. The middle circle, small circle, is nothing but the true value of the confidence interval, and this is the lower limit, and this is the upper limit of the true value. So what here I'm telling is the same. it's the same interpretation as we saw in the box whisker plot. If it doesn't overlap, then there is a significant difference. If the thing is overlapping, then I can say that there is no significant difference. So for example, here in this error bar plot, rarely or never has a significant difference for more than weekly. Suppose I am going to have more than week in sports, participating in sports, that will be significantly different from those who doesn't practice. That also brings in the pictorial way, that is error bar plot. So this error bar plot also supports the evidence which we got from t-test or analysis of variance, that is ANOVA. See, now slowly moving on to the thing to compare the serum albumin. My objective is to compare the serum albumin between cases and controls, or between the gender. If I wanted to do, then I can use a independent t-test. Before using that, check for your mean value and standard deviation value. From the standard deviation value, we are very well known it is less than half of your mean, which is nearly 2. Is nearly 2, my standard deviation is 0.3. So both cases and controls are normally distributed. I can go for an independent t-test. And here in the independent t-test, you need to first go and check for not alone normality you have to see, you should also have to see the test for equality of variance. If the equality of variance is significant, then I can go for the results which the output of independent t-test is giving. For example, here the test of equality I'm going to test. So what will be my null hypothesis? I can say all variances are equal. So that is why I've told null hypothesis, equality of variances, all the variances, both the group variances are equal. My alternate hypothesis is both the groups have unequal variance or not equal variance. So in this case, if I am going to see in the test of equality of variance is going to be significant, then what I am concluding, if it is significant, then it is equal variance. If it is not significant, then I am saying that there is a unequal variance. So if it is significant, means I support the alternate hypothesis, that is unequal variance. So we need to take the result from the equal variance. Most of the time, the p-value would slightly differ, but we need to decide upon which result should be taken, equal variance or unequal variance. So if it is going to be equal variance, you need to report t-test. If it is unequal variance, we call it as a modified t-test. And we can conclude that there is no statistically significant p greater than 0.5 difference between the male and female, because the p-value is 0.6. And suppose I am going to compare the patients with the benign and malignant lesion, then also I can go for an independent t-test, and as well I can see the standard deviation, how the standard deviation from my point of normality, this data is normally distributed. So I have used the independent t-test. And also I can say that t-test results indicate a significant difference between mean T2 values in the two groups. And this is the way how you can report the t-test. Similarly, in the paired t-test, and before therapy, tumor size has been taken before therapy and after therapy, and have found the mean tumor size plus or minus standard deviation, that is 4.86 plus or minus 0.91 before therapy, and after therapy it is 4.50 plus or minus 0.96. So in this case, I can go for a paired t-test since it is normally distributed. And similarly, to improve the HP level of 192 children aged between 14 to 17 years, weight at 6 months 192, and at baseline it is 9.89. So I know for the baseline, from the baseline, how much HB has been increased among the persons who are 14 to 17 years. It is at 6 months. So I can go for a paired t-test. And when a paired t-test, always try to report the mean difference as well as the confidence interval for the difference. And you can also write there is a statistically significant improvement in the mean HP levels from baseline to 6 months. See, for example, to test the difference between means of two groups samples, you can go for a two group sample. If it is paired or a matched or a pre and post like thing, then you can go for a paired t-test. If it is a two group samples or independent not matched, check for the equality of variance, that is Levin test or some other tests are there for checking the equal variances. So if it is equal variance, go for an independent t-test. If it is unequal variance, you can go for a modified t-test. And next thing is to assess the level of folic acid in RBC after 24 hours among bypass patients who were randomized to 3 treatments, treatment 1, treatment 2, and treatment 3. And I can go for an ANOVA. Here, always we try to go for an ANOVA, and we know whether the difference exists between these 3 groups. But my actual interest is if there is a difference between these 3 groups, whether one is different from say 2 or 2 is different from 3 or 3 is different from 1. That is as a researcher, I will have which group is different from which, or all the groups are different. That is what I needed to have. So I can go for a ANOVA. If the ANOVA, this is the ANOVA table, if the ANOVA shows a significant result, means there is a significant difference between these 3 groups, these 3 treatment groups. And so I wanted to find out where exactly the difference is, whether all the groups are different or only 1 and 2 are different like that. I wanted to see. Then I can check for Levin test and find out whether I have equal variances assumed or equal variances not assumed. That is, if you have an equal variance, you can go for so many tests. And if it is unequal variance, there are so many tests available in the SPSS. Okay, so most often, widely in the health research setup, there are 2 tests used. One is Stuckey test and the one is Bone-Ferroni test. If it is of equal variances assumed, if it is not assumed, people always go for a Dannett test. It is not that you have to go for this, but there are some rules and regulations for choosing the test based upon your data. Okay, so now I have compared using the Dannett test, the dependent variable, that is level of folic acids I have done, and I have found that there is a significant difference between first and 3, whereas there is no significant between 2 and 3, and there is no significant difference between 2 and 1. So the significant 2 and 3, there is a significant difference. See, P is less than 0.05. For 1 and 3, there is a significant difference. 2 and 3, there is a significant difference. 3 differs from 1 and 2. So I can write easily when after finishing my ANOVA, multiple comparisons done at test were used to show which groups differed from each other in the level of folic acids. It resulted that there is a statistically significant difference in level of folic acid between group 1 versus group 3, that is P is 0.002, group 2 versus group 3. However, there was no differences between group 1 and group 2, that is P equal to 0.174. This is how we will be writing. To compare the differences in vertebral density in 3 age groups. Suppose you are comparing the three categories of age group, then also you can go for a ANOVA. This is the thing, values provided by statistical software indicating significant difference. Like this also you can go for a 3-group comparison, and you definitely need to specify the multiple comparison test which you have used, that is t-test with Born-Ferroni adjustment. And suppose you are finding whether there is a relationship between weight as well as your diabetes value. See, weight is again a continuous measure as well as diabetes is a continuous measure. So if both are in ratio scales, and I wanted to prove that as weight increases, whether my diabetes value is going to increase or vice versa, diabetes increases, my weight is going to increase. Suppose like that is the scenario, you wanted to find out the relationship between the weight and the diabetes. As one increases, other is going to increase or not, you are going to find out, then you can go for a correlation test. That correlation test is nothing but Pearson's correlation test. So both are continuous value, and both the variables are normally distributed. Then you can choose a Pearson's value. If suppose instead of considering weight, I'm going to categorize them as a BMI, which is defined by our WHO, like normal weight, overweight, obesity, like that you are going to define. And you wanted to still have diabetes as a continuous value, and you wanted to find out whether there is a relationship exists. So in this case, I cannot have for a categorical variable, I cannot test for normality. So automatically BMI will not follow normality because I have categorized that. Whereas diabetes might follow normal distribution, but I wanted to find out as an increased BMI as a high diabetes value. If I wanted to have like this question, then I can go for a correlation again. Here, I need to use a Spearman's rank correlation. And suppose I wanted to categorize BMI as well as I wanted to categorize my diabetes fasting glucose level as normal, pre-diabetes or diabetic, like that I wanted to convert. And here both are categorical variables, and that is the order in it. In that case, I can go for a correlation again as increased BMI as an increased diabetes value, or increased increased level of BMI as an increased level of fasting glucose. If it is like that, I can again go for Spearman rank correlation. So whenever you are trying to find a relationship between two groups, as one increases, other increases, or one increases, other decreases, like that it is your goal, then you can go for a correlation. If both the variables are continuous and they are following normal distribution, you need to go for a Pearson's correlation. If one variable is categorical and another one is continuous, and if both are categorical or if both are continuous and not normally distributed, then you can go for a Spearman's rank correlation. So this is how you interpret the correlation, which is readily available if you Google it, or in any statistical book, they are telling how it can be done. See, for example, a researcher believes that there is a linear relationship between BMI of pregnant mothers and birth weight of their newborn. So they are trying to find out the Spearman's correlation. So if the Spearman correlation between BMI and birth weight is 0.907, it's nearer to 1, and I can say there is a strong correlation between BMI of mother and the birth weight of the baby. So I can write there is a statistically significant, strong positive relationship between BMI of pregnant mothers and birth weight of the newborn. So similarly, I can also interpret, if suppose people are doing amount of exercise will have a concern over health, like that. So if I do more exercise, my health will be fine. If you are having like that, then you can also test both the categorical. Now amount of exercise might be a continuous variable, hours, like we can say number of hours they are doing an exercise, and the concern over health might be a categorical variable. So in that case, I will go for a Spearman's score, and I can, there is a statistically significant positive. Why positive? If it is a negative, there will be a negative sign in the result. So there is a positive intermediate positive relationship, that is R equal to 0.396 between amount of exercise and concern over health. Next, we are moving on to chi-square test for proportion. See, chi-square test, whether the treatment is associated with outcome. Whatever the treatment which you are going to use is associated with outcome. Here there are two treatments, A and B, cured and not cured. I have listed. In the treatment A, there were 100 people, and treatment B, there were 150 people. So I wanted to test whether there is a difference in the treatment, or whether the treatment is associated with the outcome. So what I have found that the p-value is 0.0002. The p-value here for the chi-square test is 0.0002. For the calculated value, Pearson chi-square results show that the two treatments are equally effective with significant value. The treatment which I have given both has an equal effect on the treatment effect. the chi-square value and degrees of freedom. And suppose this is the test which results of vaccination program. The people who are unvaccinated or vaccinated, whether they are being sick, is evaluated using which has been done. That chi-square test resulted that there is a difference with significant p is 0.0011 and the chi-square is 12.35 in the occurrence of pneumonia between the vaccinated and unvaccinated groups. That is the way we will be resulting that. See, the major use for chi-square test is, even though we have a continuous measurement, we will be categorizing it and we will find how many people, how many have improved upon. See, when the question is numbers, how many, if it is going to be like that, how many people fall in a particular category and whether that category has shown a effect of improvement. If it is going to be a question, then you can always categorize your continuous value and you can tabulate as a cross tabulation. That is what I have shown here, and you can go for a chi-square test. People normally what they do, whatever we are tabulating as a cross tabulation, they will go for a normal chi-square test, that is chi-square test for association. But there are different chi-square tests which will help us to interpret or based upon your research hypothesis. See, for example, I have a question: to improve the iron deficiency anemia status of adolescent girls by supplementation of iron-rich food in their midday meal. So in the midday meal, we are going to supplement iron deficiency, iron in the food, iron-rich food in the midday meal, and we are going to evaluate the anemic. How many? See, in the pre-interventions, there are totally 55 people have been involved in the study. 55 people have been involved in the study. In the pre-intervention group, I have 25 people who are anemic, and I have non-anemic also 30 people. Okay, so after having a midday meal of 3 or 4 months, and again I'm going to see for the post-intervention. In the post-intervention, I could find that 14 people are anemic, whereas 41 people are non-anemic. So initially, out of 55 people, 25 were anemic and 30 were non-anemic. And at the end of the study, I could say that 14 people are still in anemic, whereas 41 people have improved upon. So when this is done, even though HP values are continuous and I'm trying to accommodate with them anemic or non-anemic in this case, also you can have mild, moderate, severe table, and you can find it is not always 2x2 table for chi-square. If you are putting mild, moderate, severe, you need to compare mild with the moderate and moderate with severe. So before and after intervention is your goal, then you can use a test called McEnmer's chi-square. You should not go for an ordinary chi-square. A P is for this test, p-value is 0.022 for calculated value of McEnmer chi-square. 5 with 1 degree of freedom implies that the proportion between pre and post intervention differs statistically significant. So remember, whenever you are doing a pre and post intervention or intervention of a categorical variable, or how many persons are improved upon, if it is going to be your goal, then you can go for a McEnmer's chi-square, not an ordinary chi-square. And this is the scenario where McEnmer test for paired comparisons like angiography versus CT results in the diagnosis of coronary bypass graft thrombosis patient. They have done an angiography, positive angiography and negative angiography, and whether the CT has a positive or negative. So for this reason also, because for the same person, they have done the 2 tests, so they can go for a McEnmer's chi-square, not only pre-intervention and post-intervention. If the 2 tests has been carried out for the same person, same test, the same group, then we can go for a McEnmer's chi-square. And precautions while calculating the chi-square or McEnmer's chi-square, when the sample size is small, when at least one expected cell frequency is less than 5, you need to go for a Fisher exact test. Whenever you are doing a study with 20 people, definitely one cell might be go less than 5. In that case, you need to use a Fisher exact test. For example, here Fisher exact test for small samples, patients and control has been compared for a positive CT result and a negative CT result. In this case, they will be using a Fisher exact test. And if it is, if there is a relationship exists between the mother's BMI and the birth weight of the baby, then definitely we can go and use a linear regression for predicting the birth weight of the baby with a known BMI of a pregnant mothers using our regression techniques. If all the outputs are very easy because SPSS or any statistical software is there to let you know, as a doctor, you try to understand the output of the result and link it with your clinical findings. You need not know how to do all these, but you should know what to do and when to do. That is your priority should be there. Here, if you are doing a linear regression or any regression, then you need to look into for a R square value. This R square is nothing but it is called as coefficient of determination, whereas this R square should be nearer to 1 and it should not be less than 0.50. If the R square is nearer to 1, then whatever the prediction which you are going to give predicts the reality well, very well, fairly well, I can say. Instance, R square is 82.3% indicates the variation in birth weight is explained by the independent variable BMI. Hence, the regression model is fitted well. So whenever it is more than 0.50 only, we can say this, that the model is correct. See, if you have two groups and you're going to compare the mean difference of a continuous value, then you can go for a parametric test, that is for a normal data student t-test. If the data is not normally distributed and also you're doing with lesser than 20% your study, then you can go for a non-parametric test called Mann-Whitney test. If it is going to be more than two groups, and then you can go for a one-way ANOVA. The equivalent non-parametric test is Kruskal Wallis test. And if you're going to compare within the group, that is dependent group, then you can go for a paired t-test if the continuous value is normally distributed. If not, you can go for a non-parametric test, Wilcoxon sign rank test. If you wanted to find out the relationship, linear relationship between two continuous variables, then you can go for a Pearson correlation for a normally distributed data, that is parametric test. And if it is not normally distributed, you can go for a non-parametric test called Spearman's rank correlation. Suppose you are going to compare ordinal versus continuous, that is an ordered category with a continuous value, then also you can use a Spearman's rank test, which is a non-parametric test. And ordinal versus ordinal, also a non-parametric test, that is Spearman's rank test. See, for example, if you are going to do a Pearson correlation, you can, in the result, you can say there is a relationship exists, but whenever you use a Spearman rank correlation, you need to use the word association between the two groups. So association is, association can be used only Spearman rank correlation or chi-square test are used. If you are using a relationship, it is only for the parametric test, Pearson correlation. And association of proportion, I can go for a semi-parametric test. Why I call it chi-square as a semi-parametric test? Because out of the continuous value also I can make categories. So that is chi-square test. If it is association of paired proportions, then I can go for a McEnmer's chi-square. Association of one cell less than 5, then I can go for a Fisher exact test. And if I find that there exists a relationship, linear relationship between the variables, then I can use a regression or a multiple regression. If I wanted to find a prediction for nominal outcome like case and control, present and absent, cued and not cued, and I wanted to measure the risk factors, then I can go for a logistic or multiple logistic regression. Suppose I wanted to find a prediction for ordinal outcome like mild, moderate, severe, I wanted to find out and I should have a regression in my analysis, then I can go for a ordinal regression. And this is all about statistic, which is normally we will be using in our research setup, health research setup. And advanced statistics are there, which we are not considering for this session. Any questions? This is the end of the day of our lecture. Don't keep all the questions and take at the back. It is overloaded already for you for the past 3 Sundays. So please be frank and clarify your questions. If not today, it will not be done any day. And before that, I wanted to remember, statistical significance does not imply clinical importance. Why? Because see, suppose I have a drug A, in reducing the temperature in hypothermia cases. If you have in your wards hypothermia cases, your goal will be to reduce the fever in the particular patient. So you know there is a 2 drug available for reducing the hypothermia, the temperature, reducing the temperature in hypothermia case. So what you are trying to have is drug A. For example, drug A reduces fever from 108 to 106, and there is a drug B reduces fever from 108 to 105. As a clinician, as a doctor, you will be preferring drug B. But when I put these 2 drugs for statistical significance, it will not say drug B is better than what all, it is numbers. So you're a doctor, first understand that for you, it is very, very important to have a clinical importance of the findings. And if you need to have a statistical significance, you need to do in the proper way. As I said, always my goal is to nullify the hypothesis and trying to prove the research hypothesis. If it is not statistically evident, definitely it might be clinically evident. So have wider thinking before concluding something. And people will not say if it is not significant, but nowadays journals are accepting even though if it is not a significant result, but you should know how to argue that there is a clinical significance. So always bad analysis can be read, but bad designs cannot be refixed. And also, if you torture your data for long enough, it will confess to anything. People who are coming for analysis to me, they will say, ma'am, try to change this as a categorical variable and try to find an association. It's all numbers and it's also a mission. You are the only one who are knowledgeable and to think widely about your research. So don't torture your data to confess into something. Thank you.
Thank you, ma'am. That was so nice. Let us not torture our data. Okay. Can we have Vanilla now to start her session?
Yes, ma'am. Yes, ma'am. Am I audible? Excuse me. Can you able to hear me, ma'am?
Yeah,
Yes.
you're audible, Vanilla.
Yeah. Sorry. Okay. Since I didn't get a reply, I keep checking.
No. You can share your screen.
Yes, ma'am. Sure. Just a second.
Yeah.
Can you able to see it now?
Yeah, you're
Yeah. Okay.
share.
Yeah. Okay. Since first of all, good morning, everyone. So today we are going to see about data management using Excel and software. Okay, AP Info software. So since I'm going to talk about it and do a demonstration also, it is going to be a little longer session. So let's quickly jump into the topic. Okay. So yeah. Okay. Data management in health research. Okay. So why it is not changing? It is taking time. Okay. See, data management is something which we doctors, all of us should know about it, because not only doctors, not only you're doing the research, okay, you are going to publish it, you are making to available to the world. Okay, you are going to publish the data. So for that, a good research should always have a good management of a data, okay, a good recording of the data. Even though you would have done a great research, but a poor recording of those datas and management of those datas will lead to, a bad analysis or a bad reporting. So today let's discuss about what are the various platform which can be used for data management, as a simple like Excel, or another one is a software, AP Info software, which is a free available software. I will be giving a demo on that and how to use the software for a data management and for a data collection as well. Okay, so these are the few things which can be used for a data management. A simple spreadsheet, okay, using Excel. This is Excel is what we will be using most of the time for recording our data. Okay, and next one is a program managed system, such as I told you, right? Like softwares can be used for data management, for collecting the data as well. Okay, so can you see it here? This statistical software, AP Info and SPSS, these two is commonly used in healthcare. Okay, so I will be giving a detailed in-depth about AP Info. Okay, these are the other available management softwares, which is being used in for in a multi-sector, or in a hospital setup, or in a clinical side, where they deal with the big data sets. Okay, so the uses of Excel, advantages and disadvantages. Okay, these more of a theory point of view. When I give a demo, I will be telling in detail about what are the pros and cons. Okay, a quick theory. When you use Excel for a data management, it is very simple to use it. And when you actually deal with a very small sets of data, say for example 150, 200, 250, maximum of say like a 300 to 500, Excel will be convenient. But when you use thousands and thousands of sample, that time using Excel will be a little troublesome. So I strongly advise to go with the software for using when you deal with the big data. So these are the few disadvantages of Excel. When compared to the software, these are the disadvantages. Okay, the thing is, you cannot all the fields of entry, there can be a typo error. The most common was the typo error. Okay, especially when they are dealing with the numbers, typo error are very common. But whereas when you use the software, we will have a field checks. Okay, we will give the like conditions. We will frame some conditions. So most common one is instead of 10, you are entering as a 10 as a serial number. Okay, so but in Excel, if you are typing it as 10, instead of 10 you are typing it as 100. Okay, and the next one, I mean from 10 to 100 is not possible. But let's say like instead of 10 you are typing it as 11. Okay, then there is some error with the serial number, and everything you chances of you can miss a single data sheet itself. Okay, but whereas in a software, okay, in a data management software, if you have given the serial number as if you have chosen a serial number, and there can be continuous serial numbers will be there like this. This is one small example. Okay, so data should look like this. Okay, you have a ID year, you have the age of the study participants, and one more thing I want to tell is most of the students who give data to me, there will be a column as an ID. I mean, mostly there will be a serial number. The next column will be the name of the patient. I don't want the name of the patient. This is what a statistician will think. Okay. Okay, maybe it might be convenient for you. You're typing each and every patient name, but that will be unnecessary when you when you give for analysis. So there will be there are some, they having a name as a one column and a Gmail ID and address, everything, each and everything of that particular patient. See, you should maintain confidentiality of the patient. Okay, so you can have a data sheet for your, a complete data sheet for your reference, but when you give it to a statistical analysis, you should maintain the same confidentiality. Okay, there can be, okay, they're coming back to here, there can be ID column, age of the patient, and gender. Here, if you can see, it is marked as 0 and 1. Okay. Most of the simple mistake what people do is they put a gender or a sex, whatever they put is, what they put is a small f. Okay, and the next one is they put a capital F. Okay, and the next one they put male. Okay, and with a capital M. Okay, and the next one they put is a small m. See, you should maintain a consistency, you should have some consistency. Okay, so here simple best advice will be coding. When you give the data to for analysis or for your reference itself, maintain some coding. Okay, 0 for female or a 0 for male. Here I give an example, like 0 is male, 1 is female. Okay, and height they have recorded in centimeters or inches. Okay, and whatever it is, you should mention it. Okay, when you're giving it to the for analysis. And here treatment, whatever treatment they have undergone, say for example 0 is a placebo group and 1 is your experimental group. Okay, and what disease they have, disease, if the disease condition is present or absent, many will put like present, absent, present, absent. So instead of that, just try to give a coding, and you note down the coding, whatever coding you have given in another Excel, in another sheets of Excel. Okay, so this is how it should be, and let quickly give a what not to do. Okay. See, you should take some ample amount of time to prepare your data, okay? And I will show you some example of how not to do a data and a real examples, okay? So you should basically check for, possible errors while recording the data, while giving for analysis, okay? As I told earlier, prepare a, okay. Prepare a separate code sheet for a data. Okay. One second, just a second. Yes. So, as I told earlier, yes, see, you should maintain a separate data sheet for yourself and do a little modification and, maintain the confidential and send it for the analysis. Wait, it's not coming. Okay. See, this is for a general spreadsheet design. Okay. Do not mix it. This is a common one. Do not mix the data types within the one column. A same column itself will have two informations, two sets of data. Okay, and it should be always, the data should be the raw data. Do not try to modify the data, and like however you want the result, do not modify it. Just if you have done a good study, good research, and whatever observation you have made, you need to record it, okay? And then you can give it to the analysis. Yes, date format with 4-digit years. Because now it is, say for example, 2019 or 2018, means chances of many people will write it like today is, I think, 27th December. So 27th December 2020 or 2019. This is how a proper recording of everything. When you try to give a short form, there are many chances of typo error will be there. So be brief in while dealing with the data. Again, when you deal with the missing data, do not use text to make it as a missing data. If the data is missing, you just leave the field as empty. Okay, do not type it as NA, not available, or missing, or just simply put asterisk. Okay, if you if the field is empty, it is self understood that the data is missing. Okay, and see if most of the datas are missing according to different types, unable to complete, if they are lost to follow up, something, means just mark it in just highlight it in different colors. And in the next spreadsheet, what are those colors and what is the meaning of those? What is the meaning? You can highlight it. Okay. And those are the things we have dealt with Excel. I will show you the one. Wait, I will show you the Excel sheet. I hope everyone can see it now, this Excel. Okay. Okay. See here, we are going to have some serial number. Okay, if name and age and what else? Gender and habits, present or absent. Exposure, if any. Exposure, okay. Here, what I'm telling exposure is if they have habits like a tobacco usage or a non-tobacco usage, okay, tobacco usage or either in a smoking or a smokeless form, or if they are using other than these two, if they are using any gutka or something else, okay, and that you are going to record it here. And here, exposure to the oral habits, yes or no. Okay, so let me quickly give some. Here, I don't want to reveal it, gender. I don't want to debate whether it's a male or a female. Habits here, they are a smoker. Okay, they are the person, he or she is a smoking person. Okay, so here I am putting the habit as 1. Okay, and exposure as 1. Okay, so I'm going to the next sheet. Please, all of you, this is a very simple one, okay, because since I have seen so many students doing this mistake, I'm mentioning it here. It might sound silly to others. Here, this is the sheet 1 and here is the sheet 2. You can simply go here and type the same one, which we have dealt it now, habit. And all the coding you can give it here. Okay. Just drag it how much ever you want. Habit is 1 is smoking. Sorry. Smoking, okay. 2 is smokeless. Okay. And 3 is others. Okay. They might have any other thing also. Have others. Okay. Exposure. 1 is present and 0 is absent. Okay, like this you can give your coding, okay, to your for your reference also, for your statistician reference also, you can keep the coding here. And the next one is, I will tell you a quick that pros and cons which we have seen as a theory. I will just quickly show it here. There can be so many data as you can give it here. You can go as long as you want here. Okay. how much ever you go, it is going to keep going. Okay. And it can be, how much ever lengthy also you can put. All the big data also you can actually deal with Excel. Okay. But the only thing is, Excel is apt only for a small data, as I told earlier, 200 to 300. That's what you can manage with that numbers only. Okay. And there are some that don'ts, which I told. I will show you some example, right? Let me. I hope you can able to see it here. Okay, I just. Can you able to see the screen? Any? I hope you can able to see this.
Yes.
Yes. Okay. See, this is how that person gave me the data. Okay. I mean, maybe he felt that this is easier for him, or convenient, or very much clarified for him. But as a statistician, as I cannot able to use this just like that. Okay, I need to modify this data. Okay, I need to make it something which will look like this. Wait, I will show you. Okay, just leave about all this. Okay, see, this is how I have. I have made some data cleaning I have done, and I copy pasted it to. No, it has gone lot of level of cleaning. Okay, see, this is how it should be when you give it in a software. Okay, that should be. I should
Sorry
be.
to interpret.
Yes. Yes, ma'am. Please tell.
You have opened the master sheet, but we couldn't see that master chart. Are you showing that?
Wait, ma'am. Wait.
Yeah. Thank you, Venika.
Yeah. Yes, ma'am. Sure, ma'am. Can you able to see it now? Can you see it now, ma'am?
Yes, Venila.
Okay. See, even a simple, he has given in a vertical, all the that labeling in a vertical one. Okay, it takes our time. Okay, as while we are dealing with the data, we don't like to sit and keep on clean the data and prepare the data to put it into the software. It should be very much clean and clear. That's how we like it. And instead of wasting time, we would like to put the data into the software, and we like to see what and all things can be done, how much inference can be drawn from the data. Okay, and one more example is how how you should not send the data is, one person has sent me the data, when I opened she has sent me 10 attachments of Excel sheets. Okay, when I opened the first Excel sheet, Excel file, okay, only two things were there: gender, male, female, how many males, how many females. That's it. That is one document. Another document, when I opened, it was the type of fracture. It was a dental student. Mandible fracture, how many? Maxilla fracture, how many? And you can put everything in a same sheet and in a separate column, and make it as simple as possible, and send it to send for analysis. And it will be easier for you to have everything in one sheet. Okay, or else in the next sheet, if you wanted to be very much clarified. Okay, and now quickly let's see about AP info. Okay. Okay, AP info is mainly used to design. You can use it to design the questionnaire. Okay, you can use it for to collect the data. You can create form, and you can use for data entry as well. And you can check for data validation, and you can do the coding also in AP info. Okay, so the whole idea of using a software for a data management is to keep the errors as minimal as possible. Okay, and the quality of the data will be that quality depends for the outcome of the study depends on the quality of the data you maintain, and you give it to the for analysis. Okay. So this the main idea is to minimize the chances of occurrence of error. Okay. See, this is you can have your own data sheet. You can frame it as much as possible. One best use of using AP Info software is nowadays with this all this advancement in artificial intelligence. Now everybody owns a smartphone. Okay, and most of us have a laptop and as well as a tablet, a small miniature version. Okay, and you can use all this smartphone, laptop and tablet to record your data. Okay, all like those days where we maintain everything manually in a what is it in a hard copy one. All those days are gone. Now everything is being advanced, and all those things are being transferred to this version. Online computer based thing is coming even in all those government offices, and here we also can update our research and data collection thing to a next level. Okay, you can create your own sheet. You can create your own questionnaire in your laptop or in your computer. Okay, and you can save the file. Okay, and that file you can use it in your smartphone or in your tablet. Okay, using that screen, using that form, you can keep recording up to 1,000, like as many as samples as you want. Many data you can record, and it can be keep going. Okay, say for example, if you are running a clinic. Okay, I will give dental example itself, will be easier for me. So I'm running a clinic, and patients are coming. I'm creating I just want to record. I'm not doing any research. I'm just recording what kind of patient is coming to my clinic, and what is a common complaint they are doing, and okay, what is a common problem they are facing. I just want to simply record what is the diagnosis I made, what is the treatment plan I suggested for them, whether they have come again for the appointment or not. So these are the things I just want to put and I want to record. Either you can use a Excel spreadsheet for recording those, okay, or else you can create your own this data form in your using AP Info in your laptop or a computer. You can just even in your phone you can record it. Okay, once a patient has left your clinic, I mean just gone out for the clinic, if you are free, you can just type it then and there. If say for example, I have completed details about one particular patient. Okay, and simply I can give next form. Okay, I will show you all the demos. I will show you. I can once I have completed recording that sheet, I have completed about one particular patient. Simply I can click like next form. Automatically it will get saved. Okay, next form, and the new like a new leaflet, fresh form will appear in your screen, and you can record about the next patient in that. So like this, it will be very handy to use, very much easy if once you understand about this. Okay, and similarly you can have conditions. You can put the conditions once you create the form itself. You can create all the conditions, how many, you can limit the numbers. Okay, say for example, I'm giving serial number. if I'm giving range for a serial number starting from 0 to 1000. Okay, so that 1000 is the upper limit if I'm giving. Once I am 1000 means up to 1000 datas I can, up to 1000 datas I can fill in the sheets. Okay, if I'm giving that like a condition, if I'm giving, and when I completed 1000, I did not see the serial number. I am not checking that regularly. Once I have completed 1000, when I try to give the next form, no, it will pop out. A pop out will come like error exceeding the serial number limit. Okay, so that time I will know, oh, okay, I have reached 1000 data. I have completed 1000 patients in my OPD. So okay, thereby I will know. Okay, then you can go again. You can change the limit if you want, or you can keep it that 1000 as my first 1000 patient in a separate file you can maintain. And the next 1000 you can start recording it. So this is one example. Okay, so you can have your own database. Okay, dealing with all your patients and thing. So this EpiInfo is a free software. Okay, it was developed by CDC and it was actually developed long back in the 1990s, but it was very it was not user friendly during that time. But after in the last 10 years, last 10 to 12 years, this has made tremendous changes. They have made it to be kind of user friendly, and all the manuals they have established, and it is easy. Once you download it and see for yourself, you will know. Just like how Mendeley I told you, it's very simple, very easy and free software, and daily, almost daily or weekly, they are updating and they are fixing the bugs, and you can download the latest version and start using. Okay, and these are the few fields which we will be seeing in EpiInfo. Okay, you can while creating the form itself, you can mention what type of data it is. Okay, so whether it is going to be a numeric, or it is going to be a text, or it is going to be a date, or it is just a address, residence address, or everything you can just choose, and I will show you how. And these prompt question will be displayed. This prompt is the question which will be displayed like a question in the form. Okay, and you can have a variable name. This is the prompt is the question, age of the patient. That will be the this is just example, age of the patient. That is a prompt question, and variable name I will be saying as age. This is no need to be necessarily the same as a prompt question. Variable name. Prompt question can be a lengthy. Okay, say for example, consumption of sugar per day. Okay, consumption of sugar in any form, either it is a coffee, tea, or a snack, a sweet snack, a candy, or a sweet puff, anything. Okay, that might be a question. Okay, here the variable name can be sugar exposure. Okay, so this variable name will be easier for you when you deal with the analysis. Okay, so this variable name should be short and sweet. Okay, just while seeing itself, you should understand what question was that. And length is the length you can you yourself can determine. I will show you how. And there are some options like these are the options which when you click on those box, that will happen. Okay, this is if you give it as required. If required, if you have clicked the option as required, means without completing that field, you cannot go to the next question. Okay, say for example, for age, I have put an option. I have given the option as required. Okay, I have completed first patient. Second patient, I am entering. While entering, I'm entering the data in a hurry or something. Okay, I'm just skipping I'm trying to skip the field. Okay, but since I have given the field required as a compulsory, okay, that the next field will not go. A pop-out will come and it is X, and it will say is required, age is required. So then you will once you enter the age of the particular data, and the next field can be gone. And similarly, it is a repeat last means if say for example, I'm conducting a camp, okay, I'm conducting a dental camp, okay. So in some field I have given like dental caries. I mean, I'm going to see I'm conducting a camp only for a dental caries, okay. So initially selection have been done for a caries. So all those patients are going to be a dental caries patients, okay. So here there was a column, there is a field I have created like dental caries, okay, present. If I am giving present and if I'm clicking the option as repeat last, so all the data whichever I'm entering, the dental caries will be present. That is the like automatically everything will, that field will be filled for all the data which I'm entering. And range, as I told previously, there will be a range like you can determine your own range from 0 to 100 or 100 to 1000 or 1000 to 1 lakh, up to anything you can do, okay. Okay, now let's see the EpiInfo demo, okay. Okay, wait. Wait. I'll quickly close all this. Okay. Okay. I hope you can see my laptop screen here. Here I have downloaded EpiInfo software and kept it ready. Here I have the software here. Okay. Once you have downloaded the EpiInfo software, this is how it will be. Okay. See, launch epiinfo.exe. Okay. This is how it will save it in your screen. Okay. Let us get into EpiInfo. Okay. This is, can you able to, I hope everybody can able to see this screen, this EpiInfo screen. If not, please let me know.
Yes, very loud.
Okay. This EpiInfo, you can see create forms, enter data, create maps, StatCal, classic, and the visual dashboard. Okay. These are the 4 main uses of EpiInfo, and this is a 5th use. Okay. Using EpiInfo, you can create your own questionnaire. You can create your forms. Once you have created the forms, you can use it to enter the data. Okay, so this is the first step. This is the second step. Okay, only you have created. If you have created forms, only you can use it to enter the data. Okay, and this create map is one where if you have in your questionnaire, if you have you are doing a field research, you are going onto the field in a particular place. And doing environmental study or geographical study. During that time, this map will be useful. I mean, a particular location will also can be that coordinates, longitudinal, latitude coordinates can also be saved. Okay, that is a very big use. Okay, and this StatCal is I hope everyone have remembered when even Valarmati ma'am talked about a sample size, estimating a sample size. During that time also, she told about this OpenEpi. She has, ma'am has demonstrated about how to use this OpenEpi for calculating sample size. Similarly, EpiInfo also, can be used. I remember ma'am has mentioned about this epi info for computing the sample size. This also can be used for arriving at a sample size. Okay, and the next one is this is for analyzing data as they have given here. Classic is the previous version. Okay, previously they were using only this classic was available and they have using this, but many bugs started coming it and many errors started reporting it. So they have developed a new one as a visual dashboard. Now most of us use only this visual dashboard for analyzing the data, but they are still keeping the classic because during earlier days many have got used to this classic, and now they have also fixed the classic, but they are since considering the users, they have kept the classic as well. So this is the visual dashboard. Once you have created the form, entered the data, you're all good to go to analyze the data. Okay, so let us get into create forms. Just double click it. It will come. Okay. I clicked 2 times. Okay. See, this is how this is the canvas. Okay. This is the canvas. This is where your questionnaire will come. Okay. So you need to, I will demonstrate how to create a new project. Okay. And how to type and save your data and how to enter the data. Here, just there is a field here, a new project. Okay. Just click the button. Okay. Keep the name of the project. Okay, your research project name. Okay, here I'm keeping the name as research methodology. I want to create a form about questionnaire about research methodology. Okay, remember it. Okay, there should not be space. Okay, if the space is there, it will not identify it. So once I give a project name, okay, I'm just clicking it here. It is, this epi info is creating a file. Okay, that file name is PRJ. That is a project. Okay, what project, whatever project we are doing, we are keeping a name. Okay, here I have kept a research methodology. So now epi info will create a project named research methodology .prj project. PRJ in my laptop database. It will create a form. Okay, so you can find it in the users. Okay, in the which what will say C folder. In the C folder under users, under my name, under epi info, this epi info folder, it will under the project, it will create the research methodology. Okay, and here also I want to give a similarly, please enter a name of the form. Yes. Okay. I advise you, whatever the project name you are giving, just give the form name also the same one. Okay. Here you would have given as a project name as a research and the form name as a research methodology or a methodology or a questionnaire. Do not do this mistake. It will be difficult for you to remember once. I mean, if you are creating many, and it will be tough. So whatever the project name, use a similar form name. So I'm clicking OK. Now it will create a form. Okay. It is taking a time. Okay. It is created a form. Okay. So as you can see, research methodology, page 1. You can add page 2, page 3. You can create n numbers if you want. Okay. Many questionnaires will have like 100 questions, 200 questions. Okay, like that. If you see this NHFS data and all, there will be so many questions under one section itself. So during that time and all, this will be very much easier. So here, since the time is going, we'll quickly say this. You can just drag this here, those fields here. You can just drag this and bring it here, or you can simply right click and you can have all the same one. Under new field, you will have the same one. Like just whatever it is here and everything will be here also. Okay. I'm trying to let us give title. As I told earlier, this is the question or a prompt question. You know, here I'm giving it as research methodology. Okay. So see here, this is the one thing you should notice. Here the questions can have space. Okay. But the field name, it will automatically come without space. Okay. Because this is how the variable name will be saved. So, okay. The research methodology is here. You can make it as bigger. Okay. I mean, there was a font size where actually you can click on that and make it properties. You can click. Okay. There are font size. See, font size is there and font style is there. Okay. You can use anything or everything you can align. I mean, you can choose whatever you want. Okay. I'm using it as bold since it is a title. I want it to be a little bolder. Okay. Sorry, here I have. Sorry for this. Okay. See, the next one is I want a serial number for my questionnaire. Okay. So here I'm just dragging it here. And the question is just serial number. See, this is the field name. It is coming again without any space or without this dot, which I have kept it here. The field name should be without any space, without any all this dot, asterisk, star, no this kind of special characters is allowed in the field name. And pattern here, this is what the serial number. I might deal with only single digit serial number or a double, triple. Okay, it keeps going. Okay, here I'm keeping as a 3-digit number, meaning up to 3 digits I can go. Okay, like 999. Once I have crossed the 999, I cannot enter 1000 because 1000 is a 4-digit number. So I cannot go beyond 999. So these are the field checks which conditions which we create in order to avoid the errors. Okay, possible errors. This is these are the options which we can choose. Okay, here again a range is here. Here I might give a lower as and upper as Okay, once I have reached 100, I cannot type as 101. Okay, so just you can keep this wherever you want. Okay, since I have created this, the first one will be automatically fill a serial number, and the next one I want to keep the date of the particular date. If you are dealing with the OPD, okay, just date wise you can record it. Okay, so see. So whenever you are entering, you can just click on those dates and do the fill the data. See, I can go like next month. I'm starting from this day, from December 27th. I'm starting to collect the data, and up to say next December, same 27, 2021. I want to collect it. Here, the only thing is you cannot since the actually it is not coming here. Let me check. Wait. Okay, since it's the next academic year, I think next year it is not coming. Maybe I will try to give it in. Okay, this one I will. I don't want to give a range at all. I mean, simply give this date, okay, fill this date. I mean, drop down will be coming and choose the date. This seriously, I have not used the date range so far. So while I try to give the range, it is not coming. So I don't know why this is not coming. This okay is not at all coming. Wait, let me check. I don't know why this is coming in. Okay, I will try to see why this is happening. Okay, and let's move into the topic. Move into the next field. Let me see why this is not coming. See, next here is for the first one we have seen. The next is the text one. Okay, if you want to save the patient's name, or if you want to save the address of the particular patient, you can use this. Okay, and you can have a maximum number of characters. You can I mean the letters, how many letters you want, you can have this. Okay, sorry, name, I'm just writing the name. Oh, wait. Why nothing is working? Actually, I don't know why this. There's nothing I can able to click OK on that. Just quickly give it 2 minutes. Okay, I think there is some bug has arrived, I think, because I cannot able to type this OK at all. I mean, whatever I click, it is not coming. I will, I don't know what is happening. I will show you the one I have created already. Okay, the research, using this EpiInfo, I have created a form for one of my study dental caries, regarding dental caries. Okay. Actually, very sorry guys. I don't know why this bug has arrived. I have just created this title and serial number, but I cannot able to use the next one. Maybe I
Vanilla,
can.
That's okay, Vanilla.
Yeah, okay. Yeah, okay, ma'am. I will show you how to, I mean, I have created the form, right? I will show you how the form looks. I will once you have created this form, and you have, I have actually created the form and I have completed the data entry. Okay, but you can go and view our project whenever you want. During that time, you can just click open project. Okay. And see, these are the projects which have been dealt with EpiInfo. So this is that database. This is stored in that, what we say, in the folder, C folder, it will create its own folder. Okay, actually earlier I have, prior to this session, I have created a project just simply to tell the things. Okay. So here I have created a dental caries one. Okay, I'll open this. See. Okay, this is an incomplete one. I will show you the completed one also. This is a name. You can enter the name of the patient. Okay, and address line. Address, for this address we use this. This one multi-line is there. No, you can using multi-line. You have so many lines. I mean, if you are or else if you are describing about the illness of the patient, you like a clinical presentation. So instead of address, you can give clinical presentation. You can write all the complaints, whatever the patient is telling. So that can be multi-line. Okay. So that for that you can use this a multi-line. This is the multi-line one. For this age, as simple as this a number field can be used and create this question. And the next one is the previous visit to dentist. Okay, this is a drop down one. This yes or no question is there. No, this yes or no field. This is that yes or no field. Previous dental visit, yes or no. You can click on that. And next is this options. field is there. No, using that I have created this oral cavity status. I am examining the patient and I am giving it as whether it is excellent, good, or poor. Okay, and this is the yes or no field. This fourth question is yes or no field, and the fifth one is the option button. Using option field I have created. Okay, and this is that checkbox field I have created this socioeconomic status, whether it is a low or a high or a middle. Okay, I will show you that the complete my original study questionnaire. Okay, see, since I was using my my laptop, I wanted to be keep it everything in the same page. Okay, I was seeing so many. It was done during a camp. Okay, so I don't want to create another page. I felt very lazy. I created everything in a single sheet. Okay, so as you can see it here, all the questions have this. Okay. Okay. Now I have understood this. We need to give this Q1 or Q2, Q3 before all the questions. Then only it will get created. Okay. Now I remembered. Okay. Sorry, guys. Actually, previously when I gave demo, I simply put date and everything, right? So before that, we should be putting as Q01, Q02, Q010, Q08, like that. The question number, we need to create that that one. Okay, then only it will get created. Okay, so okay, I will show you this. So once you give this 01, 02, 03, no, that is the codes. I mean, this is the first field which will get filled. This is the next one. So it will automatically jump and it will go. Okay. So I will show you. I mean, here there is a field as enter data. Let me click into that. Once you have created the form, you can simply save it. I mean, just close it. It will get automatically saved. Once you have completed the form, you can go to enter data in that epi info and you can choose the file again, or else you can simply view the form, give enter data as I did now, and it will take you directly to the enter data. Okay. See, so I have already told you, I have filled the form. I have collected data and I have filled the form. Okay. So here you can see, now I'm going to new record. Okay. So just to show you guys. Okay. See, here once I have filled the, once I've clicked the new record, all the fields like a new leaflet, fresh leaflet, the questionnaire appears new. Okay. I can put it like 200. Okay. Well, as soon as I click enter, I have clicked enter now. It has jumped to age. Okay. I'm giving it as 18. And as well, once I have typed 18 and I have gave enter, it is again jumping to gender. Okay, whether it's a male or female. And the next one, it is jumping again to socioeconomic status. It's a middle class or upper class, whatever you can choose. And automatically, as you can see, once this fourth question is completed, the fifth one is going. Okay, this is how you can complete your, you can just, it is very hassle-free once, it is, you can feel it like software, this is very difficult to use. Lots of things are there. Actually, it is very simple, very easy. There are lots of manuals available. You can YouTube videos available by CDC itself or epi info. Once you have seen that, anybody can do this. When I started using epi info, I was just fresher for this statistics and all this software. I was able to create, even though it is not very high level, I have created a decent questionnaire. I have using this. Okay. So this is the last question. Okay, this 27th question. Once I have selected like a level of education, school or college, whatever up to this. Once I have created this and enter, if I click enter, automatically it will go to the new form. It will go to the new form. Here you can see here. Yeah, I have filled 243 data so far. That was my original research sample size 243. Okay, so this asterisk it is given, it is there, no, this is the current sheet. Okay, so once I have given this and I am click, if I click the next one, this number will change 244, it will come. See it here, 244. The one which I previously filled, I mean the half filled incompleted form which I showed you guys, that was a 240, that 244 fourth form. Okay, here you can go and see all your datas. Okay, where it is? Here it is there, no, this line listing. If I give this line listing, all your variable can be viewed, all your data, complete data sets can be viewed. And here is that dashboard. From here, you can directly go to that analyze data, that visual dashboard, which I told, no, that it will take from here to there. Okay, and this is the map one. Okay, and this is the edit form. While filling the data only, I remembered, oh no, I have forgot to add something. I have forgot to, I mean, if you want to edit the properties of this field or you want to add a new field, no, then and there itself you can edit the form. Okay. So it is very easy. I will show you the line listing. See, so far I have told you, right, 243 1. See, here it is actually 243. When the one with the one last sheet, it was 244. But since only it is showing only 50 rows due to that, properties, I mean settings. Actually, it will show all the data sheets. Okay, all the data one, whatever you have entered so far. Okay. So this is how you can print the sheets also. Okay, you can again you can go to that new data. You can fill the new data also. So this is how this EP info works. Okay, so I will show you this dashboard also. Okay, this dashboard, visual dashboard, is the once you have created a form and enter the data. Okay, this visual dashboard, which I told in EpiInfo, is this visual dashboard. Okay, this is that visual dashboard. Okay, from the sheet itself, you can click that dashboard. Once you click on that, it will take you to here. And these are the 3-1 analysis can be done. You can view the data. You can view the variables, variables settings. Okay, let us view the data. I mean, this you just don't bother about the first few columns. Okay, this is for that software purpose. Okay, see, this is the data. This starting from this gender, socioeconomic, everything. See, as you can see it here, I have saved in a record list coding I have done. Okay, you need to, while creating the form itself, you will be giving the coding. Okay, I will show you that. All this, everything is 0, 1, 2, 3. And for all this 0, 1, 2, 3, for each and every question, I have give coding. Okay. You can view all this. See, if I click on each and everything itself, here itself, the mean and the total sum, everything, minimum, maximum, everything is coming it here. Okay, this is simply just to show us, you need to, if you want to analyze, you need to go into the analysis. Okay. Okay, wait. You can, once you have created, analyze the data using this, okay, you can send the output either to directly convert the output as Excel or into the Word, okay, or you can convert it to anything, okay. See, if I simply want to see the frequency. So this is the analysis part. Okay, I'm simply showing. I'm not showing in detail as time is short. Okay, I'm simply showing the frequency. If I want to see the frequency, means what frequency, age, or gender. Okay, simply clicking OK. It will come. Okay. Okay, see here it is just simply as gender is coming as 0 and 1. Go to the properties, okay. Display. In the display, you need to display list labels, okay. If I click on that, here, whatever coding I have given, 0 as male and 1 as a female, it is coming it again. Okay, so what is a frequency, what is a percent, okay, and all that is coming, total and total is there. So this is how you will use EpiInfo, okay, a 2x2 table, and so many things are there. The only disadvantages is there are some limitations of using EpiInfo is there, okay. With SPSS you can do anything, okay. Whatever you can do in SPSS can be done in EpiInfo also, but with some limitations. Okay, this in EpiInfo it will give a pooled version, a pooled result of everything. Okay, because in SPSS we will have a separate parametric test will be given under separate field, and non-parametric as a separate test. But in this EpiInfo, all this non-parametric, parametric test, everything will be given in a same. It will compute for all the things. If the data is parametric, you will take up that parametric value. If the data is non-parametric, you will take up the non-parametric value. Actually, it is like like all the 2 or 3 steps will be done in a single step in EpiInfo. But only thing is, you need to understand the logic, then use whichever is appropriate for you. You should use that. Okay, and here also this. Like how you do this graphical presentation or in Excel, bar diagram, chart, pie chart, and all that, it can be done in this also, okay. And scatter plot and everything, all this can be done here. So this is how this is about EpiInfo, okay. And here you can save it. Okay, it will be saved as a CVS file. Okay, once you have created the project, the questionnaire, it will be saved as PRJ project, PRJ. If I have created a project named DMFT, dental caries, dental caries means it will be saved as dental caries.prj. If I have I'm using that form, I have entered my data. Okay, using that data, I have analyzed this. Analyzed the data means it will be saved as a CVS file, .cvs. Okay, CVS, and that is a version 7. CVS will be saved. Okay, so this is all about EpiInfo. I know this is a short period to give in detail about the software. Okay, but this is at least you will get to know what is this and how to use this, how to these are the basic key things you would have understood, I hope. So this is about EpiInfo. If you have any query related to EpiInfo, you can put in the chat box, and I will clear your doubts for sure. Okay, so shall I move into the next topic, ma'am? Shall I move to the next topic, or
Vanilla?
Yes, ma'am. Yes, ma'am.
You can move to the next topic. Before that, it's actually the EpiInfo is very useful when
Yes,
they are. I want to add a comment about that. All PGs know when they are doing their study, they are collecting the questionnaire from the patient in a hard copy.
Yeah.
They are compiling that into an Excel sheet. So if this epi info comes into use, they can collect the details from the patient in this software itself.
Yeah,
So that
yes,
it will
ma'am.
be easy for them to export. So it will be good. Actually, in that IAOHNS site, we are welcoming all the PGs to send their doubts via mail, and we can handle the doubts individually to those PGs directly. If anyone wants any clarity, we can give them directly even after the session also.
Yes, ma'am.
Feel free to send your queries to the iaohns@gmail.com. That will be answered directly to you. So you can go ahead with the next session, Vanilla.
Yes, ma'am.
I would like to add a point. This epi info is also available as an app so that they can collect the data using the mobile.
Yeah, using a mobile. Yeah.
Okay, wherever they need not carry hard copies of the papers, they can collect through the epi, through their mobile itself, they can collect the data. Thank you, Vanilla. Thank you.
Yes, ma'am. Thank you. Yes, okay. Let's. The next topic will be bias in research. Okay. Let's. Since the time is very limited, we will quickly see not so much into detail, but I will ensure to give you a good explanation of all the thing. Okay. So wait. So the next topic will be bias in research. Okay. So before getting the topic in detail, this bias is nothing but a mistake, a common mistake which we might do intentionally or unintentionally. Okay, without knowing, or some with knowing, and while carrying out the research. Okay, which might affect the outcome of the study. Okay, you can simply think like this is a small mistake. This will not lead to anything big. So do not think like that. Even a small mistake can be misleading to many. So let's see what bias is. Okay, it is a deviation from the truth. Okay, either done intentionally or unintentionally. This bias can occur while collecting the data, while analysis, while interpretation, during the publication. Okay, if you are reporting something other than the truth. Okay, if a simple example will be interpretation bias. If you have done the analysis, you have, say for example, you have compared two groups, you are seeing which treatment is better than the other one. So during that time, everything depends on our significance level, right? 0.05. If say for example, you are comparing treatment A with the treatment B. Treatment A is a gold standard, and treatment B is your new a new treatment you are giving. You are want to compare it with the gold standard and see how much is effective with the gold standard. So you have done the analysis, and it is showing like treatment A is effective than treatment B. Okay, but you being the researcher, say this is your thesis topic, and you want to give the audience something new. I mean, your whatever treatment you have given as you want to compare with the gold standard, it is effective. So during that time, if you change those two things, you are changing everything from treatment A with the treatment B and treatment B with the treatment A. And when you are giving it like that, you are actually saying your new kind of treatment is better than a gold standard treatment. Okay, so this is a very big mistake, but you are doing it with intentionally. You are doing it, so this is a bias. Okay, this is done intentionally. So there are some things which we do unknowingly, unintentionally. Okay, so those things we will see it here. Okay, so a researcher should be aware of the following bias and should know how to avoid it. Okay, I mean, these are the things which we do unintentionally while selecting the patients, while recruiting, and while getting information from them. Okay, and we might miss out some factors like confounding factor in the data. And so these are the things which we might miss out. Okay, but you should be aware of all these possible errors so that you can avoid the bias. Okay, see, even you have done the study, but while doing the study only, you are remembering, oh, this might lead to a bias. But then also it's fine. But once you are completing the study and while publishing it, you should be reporting it in the limitations of the study. See, I have not done randomizations. For example, I have not done randomization. So this might lead to a selection bias. So the limitation, under limitations of the study, you will be talking about this, not selecting the participants in a randomized way, and why you have done like that. So this a few lines about explanation will give the your audience, your readers, some insightful view. They will not simply blindly follow you, rather they will learn from your mistake, then they will not do the similar mistake. Okay, so this is the types of bias: selection bias, information bias, confounding bias. Okay, we will see a little bit about everything. Okay, and see, this selection bias, no, this occurs when two groups are being compared systematically. If that is, there are differences in the characteristics of the study groups, of the study participants you have selected for the study. Okay, and say for example, one study group has a particular type of characteristics. Okay, and the next group you have selected, they have some different kind of characteristics. Say for example, their anxiety levels, their you can match it for anything, like age or gender, or their anxiety levels, or their their difficulty, their depression difficulties, or their stages of cancer. Everything should be in a similar way, similar characteristics both the groups should be having. So if you miss out anything during that time, it might lead to a selection bias. Okay, this is the most common type of selection bias. It can be in observational or analytical studies, your case control, your cohort study, and all the during this type of study, this selection bias is very common. It should be matched for the group should be matched for all the characteristics. Okay, that's how you can avoid this. So these are this volunteer bias and these are the few types of selection bias. Okay, this volunteer bias is when the participants select themselves for the study. They give volunteer for a particular study. Either they may be a patient patient to a disease which your research question is related to. Okay, so they might want to try out this trial or research you are doing. Say for example, a small example which I know, I'm giving this now this COVID vaccine, they are trying it out. Okay, in different countries, even in India, they are giving a trial. Okay, once they are trying in a healthy volunteers, the next one will be those who are in a exposure, those who are at a high risk to exposure, those themselves might volunteer. No, you give this vaccine to me, let me be a volunteer for this. He or she might be in a higher risk group category for getting this COVID. Okay, so this volunteer bias might lead to a selection bias. Okay, so the next one is a non-response bias. Okay, this bias occurs because individuals who do not respond to a call or mailed questionnaires which we send for a data collection. Okay, during that time, this non-response bias might occur. Okay, because example can be smokers are less likely to return the questionnaire, okay, than the non-smoker. If your research question is mainly about this oral cancer, oral habits related to them, okay, and when you are dealing with the when you are sending the questionnaires to them and through this kind of mailed questionnaires or phone like through a phone call interview, you would have got a baseline data, and after a certain period you are calling them back and getting to follow up, and during that time they might be a non-response because since they are having the habit and they could not continue the, you would have advised to quit the habit, or you would have advised to reduce the habit. They could have not done so. They could have they were not able to do so, so they might become a non-response to your calls or phones. So that might lead to a non-response bias. The next one is the exclusion bias. Okay, this occurs in a certain circumstance in epidemiological studies, okay, to exclude participants to prevent the confounding bias. Okay, like we ourselves will be excluding a certain participants or characteristics participants, so that to have a good result. Okay, so this kind of lead to exclusion bias. Okay, like exposed and non-exposed for a case control study. Okay, so during that time we might end up with the exclusion bias. Okay, and this healthy worker healthy worker, that is not a health worker effect, it's a healthy worker effect. Okay, this is the one because if you, while recruiting the patients, while recruiting study participants for your study, you might be recruiting one group with a active life, or those okay, healthy people who are who are having a daily routine, like they will be waking up like say 6 o'clock or 7 o'clock in the morning, and they will be having a meal at 8 o'clock, and they will be rushing to the office, and they will be returning by 6 or 7 o'clock in the evening, and they will have the meal and they will go to the bed in time. So if you're selecting a study group which is having this kind of routine, meaning a healthy routine, and with comparing with the another group, with those group participants might be say for example, they might be remain unemployed, or retired persons, or disabled persons. You cannot compare this group with that group, because if you want to really have a good research and a good output, means you should compare healthy activity group with the another healthy activity group, or unemployed group, or I mean, this is just an example. There's a lifestyle or the routine, everything should match. You cannot compare this with that person. This is called the healthy worker effect. Okay, because why this means is lower mortality is being observed in an employed population, okay, compared to the general population. So this is that healthy worker effect. And the next one is the information bias. Okay, this occurs while we try to collect the information from the participants. Okay, the method which we apply to get the information might lead to a bias, which might be inappropriate. So it leads to you would have end up getting little information from the participants, or no information at all. Okay, so this affects the output of the study. Okay, so these are some of the types of information possibly where and all information bias can occur. Okay, this interview bias is the one. Okay, the interviewer's knowledge can influence the participant answer to a particular question. Okay. Okay, if you say, for example, I'm just giving an example. Okay, so if I'm doing a phone call interview, okay, I'm asking that person like, do you smoke? And the immediately the tone of my voice and the question might have an influence on the another person. Okay, they might say, no, I'm not smoking. I'm not a smoker at all. Okay, if I'm asking like, do you smoke? If you, I mean, the tone of the voice and the way you are asking and everything has an influence over the participant. Okay, so this is why most of the time we you know we give the questionnaire to them, or then also there are chances of them cheating the answers. But in general, this interviewers has an influence on the participants. Okay, then the next one is a recall bias. Okay, those with a particular outcome or exposure, they may remember events more clearly. Okay, for example, when you're having a case control, or for example, um, if I say for if I'm this might sound this thing, if a mother, a pregnant mother, if she is if she has experienced some difficulty during the during her course of a pregnancy, if even after 10 years or 20 years, if you ask her also, she will remember the difficulties she has gone through, will remember it very well, because those who have suffered will remember it very well when you compare it to the other group who have not suffered at all. Okay, this is a kind of recall bias. Okay, I mean, the particular incident might have made an impact on the individual. Okay, they might remember it well, whereas other group or other person, maybe that incident would have not affected them at all, or they would have some kind of a memory loss, or they would have not remember it much. So this influences the information you get from the participants. Okay, the next is a reporting bias. Okay, this is the participants, they might collaborate with the researchers and give answers in the directions they want, or their interest. According to their interest, researchers' interest, the participants' results, their answers might be to the questions. Okay. Then the next one is a Hawthorne effect, because this one is, if we are being monitored or watched continuously, we might act differently. Say, for example, there was an example which I studied, which came across for this effect. Okay, there was one study being conducted at a factory. Okay, to observe, they have made some changes in the, say like some lighting settings. They have made some changes, and they want to study, does this have any impact on the production of the unit. Okay, since the workers are being monitored, okay, constantly two persons are employed, and they are being they are watching the workers work continuously, and they are recording everything. These workers feel they feel some pressure, or since they are being monitored, they work very well, and the production was actually high compared to the previous one. Okay, once the study was over, and all the production was gone back to that normal, meant that reduced level, not the reduced level, the previously how much ever they were, like say like 40% production was in a day, in a single day, they made a 40%, means during the study time they made a 60% of the production. Okay, once the study was over, again they went back to 40%. So this is that effect. The next one is a lost follow-up. Okay, this is those that are lost to follow up, are who withdraw from the study. Okay, maybe different from those who are being continued followed for the entire study. This everyone know, lost to follow up. And the next one is surveillance bias. This is the group with known exposure or outcome may be followed more closely, or say longer than the comparison group. Okay, that is a surveillance bias. Okay, and the next one will be confounding bias. Okay, this is say for example, age, sex, these are the most common confounding factor during a study. Okay, this is when say when another when another exposure exists in the study population besides the one being studied. I will give you, I have given here 2 examples. I will tell you in detail about that. Okay, that confounding factor might have an influence is associated with the exposure as well as the result. Okay, that is a confounding factor. Say for example, age is the most common confounding factor because age is associated with so many diseases and exposure. Okay, we will see in the next slide. Okay, and as I said, it can be risk factor for the disease independently other than the factor you want to study. Say for example, smoking condition. Okay, other than smoking condition or any other exposure you want to study. Okay, say okay, smoking, let's be with the smoking itself. Smoking is a risk factor for oral cancer as well as hypertension. Okay, it links with many other diseases. Okay, so that might be a okay, let's go to the next example. Okay, see here we have a study dealing with coffee drinking. They want to associate coffee drinking and a heart disease. Okay, here smoking is the confounding factor. Okay, it's a confounding bias because studies have found that if you're a regular coffee drinker, if most of the regular coffee drinkers have a smoking habit. Okay, and this, I mean, this is not my opinion, and this is what research has found. Okay, most of the it can be either way. Most of the smoking person, once they have taken a puff, they are having a coffee, or a coffee person who is a regular coffee person smokes. Okay, so these are like this here smoking is a confounding factor. Here in the research study, they want to see it like whether a coffee drinking habit has any influence on the heart disease. Okay, so but they are missing out that smoking is the another factor in the study which might influence the outcome, that is a heart disease. Okay, because a smoker has a nearly 40% increased risk for having a heart disease. Okay, so this here smoking is a confounding factor. Then the next example will be physical inactivity and a heart disease. Okay, here again they are like a two-way link is here. Physical, as age increases, one can become physically inactive. Okay, as well as as age increases, chances of heart diseases are high. So here age acts as a confounding bias. So these researchers should remember all this and they should act accordingly. I mean, once they have done the study, they should use this confounding factor and they can do analysis according to that. I mean, using this, they can do multivariate analysis. They can use this confounding factor and they can see, okay, those smokers and non-smokers, they can group it like that, and they can see what is the percentage of the heart disease they have, and they can create a criteria for this age below 40 and 40 to 60. They can group the age and see their outcome accordingly. Okay, so and these are the things where you can control the confounding factors. Okay, these during this restriction matching. Okay, and okay, see, during this this restriction matching randomization, this can be adjusted during the while designing the study itself. Okay, while designing the study itself, you can try to do this. I mean, you try to control the confounding factor while designing the study itself. Okay, that is matching for this group. As I told earlier, right? There's two groups. If you want to match it for everything, you match for all the characteristics: age, sex, race, and disease present or absent, and a similar kind of disease present. And another one is a randomization. Randomization is a very key tool for it. Avoids many bias actually. Okay, and the next two, the stratification and multivariate analysis, this can be done during analysis stage. Okay, during the analysis, you can stratify your data. You can apply multivariate analysis. Okay, using this confounding factor, and thereby you can control the confounding bias. Okay, so that's our topic. So thank you, everyone. Thank you. I thank the organization for letting me do this, take the sessions, and it's a pleasure taking the session. Thank you, ma'am. Thank you, sir.
Thanks, Vanilla.
Yes, ma'am. Thank you.
And as you rightly said, the bias is very important when you are selecting the study sample. We used to say we cannot compare. Am I audible?
Yes, ma'am. Yes, ma'am.
We cannot compare apples with oranges. That's the usual sentence we used to say when we are selecting the samples. So, and you rightly mentioned about if we are not excluding someone, or if some bias has happened during the study, that can be mentioned in the limitation. And that's a right point that has to be added to the thesis. Because every thesis should have their strengths and limitations at the end of the discussion. So that will also be helpful. Thank you. Thank you for sparing your time. And I would ask Valamati ma'am to go to her topic. Thank you, ma'am.
Hello.
Yes, ma'am.
Am I audible?
Yes, ma'am. Yes, ma'am.
Yeah. This is very simple topic, but we felt that you all should know this rates, ratios, and proportions. With these measures, if you are an epidemiologist or a community person, you have so many things need to calculate using these three concepts. So it will reflect whenever you do a community-based surveys. That time it will be very so for a cross-sectional study, and many of the studies where we are calculating the measures are basically rates, ratios, and proportions. Yeah, a rate is nothing but the occurrence of some particular event. It might be a development of disease or the occurrence of a death in a population during a given time of period. All these rates, ratios, and proportions are fraction basically, and it is multiplied by a multiplier. It can be a simple multiplier, 10, 100, or it can be a million also. So we are going to deal with the population during a given time period. Then it becomes a rate, like incidence of a disease. You can have it as a rate. And various categories of rates when you look into a community-based survey, and you need to consider certain things as vital statistics which is needed for the government are all rates, like birth and death rates. Unstandardized rates are there, and specific rates like specific causes. Tuberculosis is a for a longer time you're dealing with those diseases, and so we need to know now COVID. We can know the rate of mortality in COVID. Similarly, specific groups like age-specific groups, which age group is having the rate higher or a cure rate is higher in which age-specific group during a pandemic or an epidemic, or sometimes it is a specific time periods. Standardized rates might be a direct method or indirect method. I will be collecting age and sex from all the age groups and gender, all the genders, and I'll try to standardize some values like your percentile birth chart, like that. All those came into existence with the basic information of the rates which has been calculated earlier. A ratio is a result of dividing one quantity by another. It expresses a relation in size between two random quantities. The numerator is not a component of the denominator. It is usually expressed in the form of ratio. X is to the colon which you are seeing, X is to Y. This is the colon. Usually ratio is expressed like this, like X is to Y or X by Y is the ratio. Normally in a research setup, people used to give male-female ratio, like doctor population ratio, like that we can give like woman doctor versus men doctor ratio, like that we can give, that is the ratio. And remember that the numerator is not a component of the denominator. See, when I say ratio, the ratio of white blood cells related to red cells is 1:600, meaning is that 1/600 or we can say 1/600, meaning is that for each white cell there are 600 red cells are there. That is the meaning for 1:600 or 1/600. Example 2c, suppose I'm going to have like this, the number of children with scabies at a certain time or on a particular time period divided by the number of children with malnutrition at a certain time. This is going to be your ratio. And proportion, a proportion is a ratio which indicates the relation and magnitude of a whole. The numerator is always included in the denominator. The proportion is usually expressed as percentage. Many times when we calculate proportion, like your prevalence, all those things are carried as a multiplier of 100. When we consider the population, we will be using a million or a lakh like that as a multiplier. Here it is a proportion, so I use 100. So whatever we are going to express in percentage becomes the proportion. And also the numerator is always included in the denominator. Here the same example which we have seen earlier is the number of children with scabies at a certain time, okay, divided by the total number of children in the village at the same time. So if you could see the difference, with scabies at a certain time divided by the number of children with malnutrition at a certain time becomes a ratio, whereas when I consider the whole lot of children, then it becomes a proportion. So the numerator is always included in the denominator. What is numerator? The upper part of any fraction is the numerator. Why I'm telling this? Doctors are involved in so many clinical aspects and treatments, and always they think in the angle of biological perspective. When comes into calculation, definitely they will have some hesitation. Even with a simple proportion, they might think a lot to whether to calculate or not. So numerator, when I say numerator, is nothing but upper part of a fraction. It refers to a number of an event like sickness or birth or death or episodes of sickness has occurred in the population during a specified time period. So the numerator is a component of the denominator. Denominator is nothing but the lower part of the fraction. The numerator is a component of a denominator in calculating a rate, but not in a ratio. So when we calculate rate, it is a part of the denominator, but when we calculate ratio, it is not a part of the denominator. Denominator is nothing but numerator has a little meaning unless it is related to the denominator. If you don't have a denominator, we will not have a ratio or proportion. So numerator doesn't have a meaning unless we have the denominator. So the epidemiologist has to choose an appropriate denominator while calculating the rate. So most of the time it is used in the vital statistics where we need to know certain rates. they may be related to the population or they may be related to the total event. For example, related to population, we might calculate a mid-year population, or we might have population at risk at a certain time, person time, or a person distance of some populations. And when we say that total events, the denominator may be related to the total events instead of the total population. From total events, for example, if I wanted to find out find out a risk among the cases and control, then it is related to the total events. Not among cases, how many events are observed, and among controls, how many events are there. Then it does not consider the total population. Only we consider the total events. Here, the proportion you might have seen while ma'am has dealt with the diagnostic test, she has shown this 2x2 table. Here, if I wanted to find A by A plus C versus B by B plus D, then it is a proportion. A by A plus C is a proportion where A is the numerator and A plus C is the total. So it is a proportion. And when we say relative risk, that is also risk is also a proportion wherein A by A plus B, A divided by A plus B, the total risk group that is having positive disease. So A by A plus B we are doing. So it is a risk and we call it as a relative risk. And odds ratio. So if you can, once you say ratio, the ratio means, see, suppose the odds ratio is nothing but, as in the earlier class, it has been dealt AD by BC. So here you could see that numerator doesn't have a connection with the denominator. So AD by BC is a ratio. So numerator is not a part of your denominator. So ratio is that numerator will not have a part of the denominator. So entirely they will have deal with different two measures. And in a diagnostic test, sensitivity and specificity are all proportions, whereas odds ratio is a ratio. So this is all about, remember that numerator is a part of a denominator, then it's a proportion. Numerator is not a part of the denominator, then it is a ratio. So that's all about rates, proportion, and ratio. See, if you want to have further reading, and definitely you are involved in a community-based survey, and these measures, rates, proportion, are important to you, you can go to the CDC, Center for Disease Control website, wherein they have given so much of information about these vital statistic measures, wherein you can use that. So always go and browse through CDC to know the measures of vital statistics. Or if you want to know further in rates, ratio, proportion, you can visit Center for Disease Control website. Thank you. That is NIH website. Thank you.
Thank you, ma'am, for a brief summary about rate, ratio, and proportion. And shall we quickly go on to the next topic?
Yes, ma'am.
Yes, I'm sharing my screen. Is it visible, ma'am? Is my screen visible, ma'am?
Yes, ma'am. Yes, ma'am.
Okay.
The article submission.
Yeah. Yes, fine. Good afternoon. This is about the article submission, plagiarism, and publication ethics. The principles of ethics. So it is to respect the autonomy, justice, beneficence, non-maleficence. So what is the autonomy? Autonomy is to respect the individual to take their own decision for the willingness to participate in the study or not. That is autonomy. And justice is to give them equal opportunity to participate in the study. Sometimes we should not deny any group that we will not include them in the study. Everyone will have an equal opportunity to take part in the study. That is justice. And the beneficence is to do good, to be fair and correct in all actions, and must take steps to prevent any harm. Whereas non-maleficence, even if we are not able to do good for the participant, at least we should not harm them. So do not harm is the non-maleficence. There are certain guidance documents that is available for ethics for the study. So first it is started in 1947 by Nuremberg Code, and 1978 to 79 is the Belmont report that majoritarily used by many people. And we have an ICMR code also for guidelines for public research, ethics for the research. And the Institutional Ethical Committee or Institutional Review Board, this has a certain role. That's the study have for any potential benefit to the individual or community. This has to be reviewed by the Institutional Ethical Committee. And as the participants' rights are well protected, does the benefits outweigh the risks involved in the research, and does the participants have access to the study findings and benefits, and is there a mechanism for safety provision and support to participants? All these things has to be taken care by the Institutional Ethical Committee. And if there are any vulnerable population is involved, like children or pregnant women, additional safety measures have to be taken care. And ethical clearance has to be obtained before starting the study and even before enrolling the participant. And ethical clearance has to be mentioned in methodology section, even in the protocol of the study. And finally, also in the thesis and article when we are submitting. Any change in methodology while doing the study has to be brought to the notice of the ethical committee and get a written approval for the change. Then only it will be valid. The composition of Institutional Ethical Committee, it is multidisciplinary and multisectoral. Usually it has a chairman, secretary, research experienced persons, social workers, legal advisors, and some lay persons also. So what are the common ethical issues? One is the provision for protection of human rights and ethical issues, measures for protecting confidentiality, appropriateness of the informed consent, mechanisms for reporting and management of adverse events, care and support for the research participants, reimbursement and compensation, and continuing review of the progress of the study, and competence of the research team. Each part is very important, and all these ethical issues has to be handled properly by the ethical committee. The importance of scientific review. The scientific review explores the scientific novelty and rationality and relevance and justification for conducting this study, the merits and feasibility of this research project, and the soundness of the study can be assessed by looking into the inclusion-exclusion criteria, sample size, randomization, blinding procedures, study techniques, follow-up plan, and outcome assessment. By all this, when we are submitting the protocol in the Institutional Ethical Committee, while we are presenting in the Institutional Ethical Committee, all this thing will be designed in the protocol itself. So by looking into all these things, the scientific importance of the study can be looked into it. There is a separate board for monitoring the data and the safety. And next is about the informed consent. This is a process of informing the potential participants about the proposed research in a systematic manner and empower them to take an informed decision to participate in the research study. This process can be repeated several times during the research study if needed. And when we are doing a community study, a group consent can be taken, but this cannot replace an individual consent. So these are the component of an informed consent. Assent is the consent given by 7 to 18 years of children. If the consent is given by these children, it is called as assent. In the informed consent, the following components has to be addressed. It should declare about the purpose of the study, expectations from the participant, responsibility of the investigator, risks and benefits in the study, any alternatives available, and options to withdraw from the study, financial implications, if any, principal investigator details, and also the confidentiality. So the language used has to be simple with good clarity. Translations and back translations in participants' mother tongue has to be there, and witness has to be impartial. And nowadays, we have audio consent, video consent, and pictorial consent too. Video consent is very important because even for pre-operative consent, when you're taking, the video consent holds the most important in the court of law, rather than the witness signing there. So there is a separate room arranged for that, and the doctor, the witness, the patient's relatives, patient, everybody will be there to give the video consent. Even for undergoing study, and especially some invasive studies, when some invasive procedures are involved, video consent holds a better option. If the vulnerable participants are those who lacks the ability to fully consent for the study. The patient information sheet. This sheet has to be provided separately to the patient apart from the informed consent sheet. This will be with the patient. So this sheet should contain the following data, following information. One is the title, nature and purpose of the study, identity of the research team, who is doing this thing, how many people are involved in this research, the duration, tentative duration of the study, number of participants who involved in the study, any procedure or investigation that is going to be there in the study, risks and benefits, in compensation policy, alternative procedures if any is available, confidentiality details that has to be mentioned, and institutional ethical committee's chairman's contact details has to be there in this information sheet. Because if the participant has any problem with the research team, he can directly contact the ethical committee chairman, and he can report about that. And investigator responsibilities has to be clearly mentioned, so that the participant can question if any investigator doesn't fulfill their responsibility. If, during the study, if there are any risks or injuries that has happened, the treatment for those has to be mentioned, and who is going to bear the cost for the treatment, whether the investigator is going to bear or the institution is going to bear, that has to be mentioned. And if study is getting in genetic studies there, or HIV study, HIV related studies are we are doing, counseling regarding that has to be mentioned in the patient information sheet. And when we are collecting a biological sample, how we are going to store the sample, and what is the policy we are going to follow for discarding the sample, everything has to be mentioned in the patient information sheet. And if any patient or participant wants to withdraw from the study, there should not be any penalty, and there should not be any loss of benefit on withdrawal, and there should be freedom for them to withdraw from the study. And if there is any benefit that is going to arise from the study, commercialization of the benefit, for that also we have to get the permission from the participant, and that has to be mentioned in the patient information. And also regarding publication rights also, we have to inform the patient participant. The components of a publication ethics. So this till now we have dealt with the study ethics of the study, or ethics of the research work that we are doing. Now we are going to see about the ethics related to the publication. So this ethics is a following components. One is the ethics review. Next is fabrication and falsification, authorship, plagiarism, submission ethics, and conflict of interest. So the ethics review, that is the ethical clearance obtained for the proposed research project. A human or animal ethics committee approval has to be obtained for all the study. Is also, this ethics review is expected in situations involving no risk. That is, when we are using only data also, that for that study also we have to get an ethical clearance from the institutional ethical committee. Even when only minimal risk is involved, that is, we are asking only questions, no intervention or no specimens are collected, even then ethical clearance is mandatory for all the study. And informed consent has to be there. And if we are doing any clinical trials, we have to register in that clinical trials registry, and data has to be maintained confidentially. So regarding clinical trial registry in India, this has the prospectively register the trials before enrollment of the participants, and also to prospectively register with full disclosure of the trial data, to improve transparency and accountability, to improve the validity. to ensure adherence to the accepted ethical standards and to ensure reporting relevant results of the registered trials. So to ensure all these things, the trial has to be registered in the clinical trial registry before starting the trial. Fabrication and falsification. So in what is fabrication? If the researcher is doing one study and totally he's taking a result from any other thing, or he's not taking his own result, that is completely fabricated study, are completely cooked up. That is, the results were not generated from the study that is conducted. That is fabrication. Whereas falsification is the researcher is doing a study, he is getting on data, some things he is modifying to bring the result which he wants. For example, if you are doing a study like a conventional tonsillectomy and dissection method, if you are comparing, and if you want to say that coblation the method is better than the conventional method, the blood loss in coblation is minimal. We are adjusting the data accordingly. That is falsification. Whereas fabrication is entirely the study is totally cooked up. That is fabrication. Both are serious academic misconduct, and all the case report forms and data should be preserved. Then if we have cooked up any data, that can be seen with the case reports, and any journal can ask the researcher at any point of time regarding this case reports. Authorship. This confers the credit, implies responsibility and accountability. It is mandatory to declare the contribution of each author. When you are submitting the research work, there will be one specific area where the contribution by each author will be declared there. And criteria for authorship should be substantial contributions, drafting the research material, final approval and agreement. While we are submitting, there also we have certain ethics. We are doing one study and submitting the same manuscript, same time to a different, to two or more different journals. That is called a simultaneous submission. And if we are submitting a new manuscript with the same study, just changing a little bit heading and a little bit in the methods, but the data is the same, that is a duplicate publication. And self-citation. So we have published an article previously, and if we are citing that article in our next article out of context, without any relation, we are citing to improve the citation factor of that article. If we are doing this, that is also a submission ethics. It's a self-citation. And predatory journals are the journals which has no peer reviews or less peer reviews. So next is plagiarism. The wrongful appropriation and stealing and publication of another author's language, thought, idea, or expression, and representation of them as one's own original work. This is an academic dishonesty and a breach of journalistic ethics. So the types is direct plagiarism, which means if we are taking from another study, another person's study, all the data or anything, a sentence or a paragraph, anything, we are taking from another researcher's one, that is direct plagiarism. Self-plagiarism means we have submitted one article and we are copying the same thing and we are putting it in for our next article, that is self-plagiarism. The same way redundant publication is duplicate publication with the same data. If the same words and same sentences of our previous study is used, that is self-plagiarism. Same data of our previous study is used just by changing little bit in the title and little bit in the method, that is redundant publications. Plagiarism is not only about copying the whole work. It can be anything, a whole document, a paragraph, a sentence, a distinctive phrase, a specialized term, a pictorial element, or a specific data. Anything is a plagiarism. And exceptions to copyright. If you use less than substantial part, or if you use it for a non-commercial research, or if you are using it for criticism, review, and reporting the current events, and teaching in educational establishments, these are all few exceptions to copyright. So what are the methods to avoid plagiarism? We have to use our own words. avoid copy paste. Instead, we can paraphrase or rephrase. When we are using in discussion part of the article, we will refer to the other person's study. There, we have to paraphrase or rephrase without changing the meaning. If needed to quote verbatim, we have to quote within the double quotation marks and give reference to the original. But even then, this will count in the plagiarism count when we are checking finally. So it is seldom used in medical research. And we have to acknowledge the source for idea, opinion, statistics, graphs, or drawings. And we have to give appropriate references, citing of the references to the original source. And we have to avoid writing several types of same articles, same articles. If we have to avoid several articles of same type, or a monotony we have to avoid. And you have to use anti-plagiarism software such as Turnitin, Grammarly, and Urkund. These are all available softwares for checking plagiarism. Yes? Yeah. Is it okay, Vijay, now? Yeah. Yeah. Thank you. Next is about the conflict of interest. The financial, personal, social, or other interests that directly or indirectly influence the author. That's the conflict of interest. And we have to disclose that such conflicts during submission. So what are the consequences of misconduct? The Committee on Publication Ethics can take an action on the researcher based on the type of misconduct, whether it is major or minor, and the researcher can be blacklisted by the member journals. Even the institute can take action. So what is the need for a publication? The need is for one is the academic progress, even for a career promotion, these publications are essential. And to communicate the research findings, to identify the research gaps and potential areas for future research, and change the existing practice methods. Even in my first session, I've shown an example of a cochlear implant in hypoplastic nerve. The previously hypoplastic nerve we were not included, was not included in the indication for cochlear implantation. And later, due to good results, and the results were published by the eminent surgeons, there was a change in existing practice. So this helps in change in the existing practice methods. Submission of articles. The instruction to authors will be available in the journal site. Step-by-step submission should be followed. Abstract and keywords are very important because that will give a The keywords especially will give the more citation. If we put an appropriate keyword, and if any other researcher is searching for that keyword, using that keyword, our article will come first. Manuscript without author and institution details should be there, and tables and figures to be uploaded separately, but there should be cited within the text should be there. The title page should contain the details of the corresponding author and address with all author affiliations and details. There should be a separate author agreement letter with signature from all authors, a covering letter to the journal, a copyright form, a strobe checklist, the contributors form, what each author has contributed, and declaration about the conflict of interest. All these forms have to be submitted. So I'm showing an example for how to submit an article. So this is a journal, International Journal of Pediatric Otolaryngology. I have opened the tab, the International Journal of Pediatric Otolaryngology. First and foremost thing is to see for the guide for authors. So this is the guide for authors that we have to go through before submitting any article to any journal, which will give an idea what the journal is expecting from us and how we have to submit, in which font, which font size, what are the tables and figures has to be mentioned in which JPEG form or a TIFF or whatever. Everything will be available in the guide for authors. Each journal has its own guide. And in this, the last part, we have the journal metrics. And also here, we have the journal metrics. This will show what is the rate of this journal. That means the impact factor is 1.2. It's a good impact factor. The site score is 2.1, and 5-year impact factor is 1.44. All these are very important to choose a good journal. So next is, we have to go for this, click this submit your paper. If we click this submit your paper, this page will open up. In this page, if we are a new person to log in, we have to go for this register now. Or here also there is a register. That option is there. We have to click that register option, and the questions of the form, we have to fill all the questions that has been asked in that page, and we can submit. If we are already registered, we have to go for the login, and if we are an author, we have to go for author login. If you are a reviewer, we can go for the reviewer login. So when we click this author login with the username and password typed, click the author login. Here also there are instructions for authors are available. If you want, again double check here. Instruction for reviewers is also available. So once we enter this username and password, we'll get this page. This is the home page. In this, we get many options. Submit new manuscript, submission sent back to author. If they have sent it back for correction, that will be mentioned here. Yeah, any incomplete submissions we have, that also will be highlighted here. So we will be able to click that. Only if this blue color one, that is the one that we'll be able to click. So if we have any incomplete submission, this will be highlighted like this in the submit new manuscript. And submissions waiting for author's approval, submissions being processed, everything will be there. And revisions. So in my account, I have one revisions being processed. So that is highlighted here. So when we are going for a submit new manuscript, this page will come. Here we have to select what is the type. It's the article type selection. This is the one. And we have to select which type of article, full length article, case report, review article, what is the type we are going to submit. So we put it as full length article if it is a full length article. Next comes the other submissions. Here attach files. This is about the manuscript attachment. We have to attach here from where we can browse from our desktop and we can put it here, or we can drag it and drop it here. So this is about attach files. The next, when we want to, after finishing this attachment, we have to click this proceed button. Since I have not attached any file properly, this is showing red. If we have attached properly, this will show like this green tick will come. So here is the general information. General information is to select the subtopic, which subheading we are going to submit our article. So here there is something called as add classification. We have to click this add classification. The subtopics will come here. So whether our article belongs to which category, audiology, implantation otology. If my cochlear implant article, I can select those things. And after selecting, we can select multiple things also. So after selecting, we have to put this, click this add button. It will come here. What are the selected classification? The next is the reviewer preferences. We can also suggest few reviewers of choice. So we can go to this add the suggested reviewer and give the reviewer details. Usually they'll ask the reviewer's designation, reviewer's qualification, his email ID and phone number. We have to give that for the suggested reviewer. Then we have to proceed. Since that one is not a mandatory thing, even if you are not giving, the green tick is coming. The next is about the additional information where we have to give the confirmation about and acknowledging that this article has not been submitted anywhere. That kind of questions will come. We have to acknowledge that. And any comments personally to the editor that is not shown in the manuscript can be given here. We can put a covering letter also here. Finally, the manuscript data. Here, the full title. First, we have to enter the full title. Next, the abstract. Then after entering the full title, we have to click this next button and we have to put this add our abstract. Then next we have to click the next button and keywords, authors details. We have to give the complete details with their email ID, their authorship, whether they are first author, second author, corresponding author, or the authorship details, their contribution towards the study, everything has to be mentioned in this authors column. And the funding information, any funding is involved or not, that has to be, that information has to be given here. And if we are sure of the submission is complete, we can go and click this bill PDF for approval, and the PDF will be built and it will be sent for us for approval. We can go through that, and if we have any change in that, we have to go for edit submission. If we are not sure about all the files, we can put it as save and submit later, and later we can submit. So once we have put the save and submit later, we are going for an incomplete submission. I told in the beginning, the home page, there is a column called incomplete submission. If we click that incomplete submission, this will ask. There are 2 incomplete submissions in this, and I can select this and continue for further submission. And after the submitting also, there are options like edit submission, remove submission, and send an email. If we want to edit submission, we can go and click and edit the submission. If we want to totally remove the submission, because sometimes a journal may take a very long time for responding, we can give a correspondence mail and then remove the submission also. That option is also available. So for revision, when a reviewer has sent their comment, we have to address each comment separately. In the manuscript also, we can do the revision with the track changes attached. And we can provide a rebuttal to reviewer's comment separately via tabular column. And in that time also, we have to follow the publication ethics. And if we want to withdraw any submission, we have to give a proper communication to the journal and then only withdraw the submission. And we have to select a suitable journal based on their journal index, like it should be indexed in PubMed, Scopus, or Google Scholar. It has to be a peer-reviewed journal with good impact factor and publication fee. Mostly, good peer-reviewed journal will not have a publication fee, whereas open access journals will have the publication fee. Impact factor is the measure of the frequency with which the average article in a journal has been cited in a particular year. It is used to measure the importance of or a rank of a journal by calculating the times its articles are cited. So the journal impact factor is the average number of citations per article per year in that journal. Whereas citation index is a bibliographic index, an index of citation between publications, allowing the user to easily establish which later documents cite which earlier documents. Vijay? Yeah, that please comment is coming. Should I wait or can I go ahead? Can I go ahead or should I wait? The bibliometrics and citation analysis. The citation count is the number of times an article is cited by other article. That is citation count. Whereas H index is to quantify the impact and quality of the published work of a scientist or a scholar. This is for that particular researcher, not for the journal or not for the article. So if one person's H index is 20, that means he has 20 papers cited 20 times or more. And I-10 index is the number of publications with at least 10 citations. ORCID is the Open Researcher and Contributor ID. This is a unique ID for any researcher. So it's a non-proprietary alphanumeric code to uniquely identify scientific and other academic authors and the contributors. ResearchGate is a social networking site for scientists and researchers to share their papers, ask and answer questions, and find the collaborators. Thank you. That's all for today. I think before going for that exam, Vijay, Dr. Mohan Commissioner sir is online. Good evening, sir.
Rama, it's an excellent session. Really mind-blowing, very useful topics. Every one of them has been, outstanding. I hope, people have enjoyed as much as I have done. It's been a fantastic 3 weekend. Every one of them has been useful, and today was no except wonderful session. So thanks, very helpful, very informative, and for people, it's been a very informative session overall. Now, before I just conclude, I just want to, emphasize one little fact, that is that Indian Academy, takes this very seriously. Indian Academy takes the job of encouraging young researchers as a very serious part of its activity. And therefore, to help this, we have created a separate committee which will be the research methodology committee, and headed by Dr. Senthil Vadivu with her team, be part of a team. So one of the things the idea is to provide a free service to young researchers, whether they are residents for the thesis work or whether it is for publication of work by young top researchers. So this will be a free service. You can mail the Academy with your problems at any point of time. Hello?
Yes, sir.
Yeah, sorry.
Sir, you can log out once, sir.
I know, I'm logged to both. As I was saying, we'll have a free service, and anybody can use this service. The only prerequisite is that you use part of the publication or the research project. Your guide, your assistant professor or whoever is guiding you or your professor should be part of the Indian Academy. And you can quote that membership number and then you can send your query. I would also encourage all the Indian Academy because it is really, meant for this. It is a totally academic body which encourages research and fostering of knowledge. So if you're not a member already, then please do become a member. You can contact the Vijay Krishnan secretary or just go to the website. You'll get all the information. But definitely any questions regarding your thesis, even before you start your thesis, whether your proposal is in proper format, whether you need any funding assistance, how to put up a proposal for that, every information you can get. All the information has been given to you over the last few weekends, but you can still get additional information if you want from this team. And I don't have to tell you how good this team is. And again, so you can be very sure about that. We take it very seriously. So you don't have to worry that if you give your research proposal, somebody else will be, taking it. It's not going to happen. So all the best. Thank you once again to this team for remarkable work, the last few weekends, to Dr. Arunmati, to Dr. Vanilla, to the whole team, and to, of course, Sendil Vadivu, who would put them all together. I think we'll have a repeat of this after a few months because there's so much of demand for it. But right now, I want to just say thank you to all of them. Thank you.
Thank you, sir. Thank you, sir, for giving this platform, sir, through IAOHNS. Sir has put all initiatives.
I think it was one of the most sensible things I ever did.
Thank you, sir.
Thank you, Vadiva. Thank you. All the best. Yeah.
Thank you, sir.
Carry on with your work.
Thank you, doctor. Thank you, doctor.
Dr. Vijay? I will share the thesis related queries now. We will answer that. And by the time you can put the questions for that exam part of questions, no? That you can share in the website. Shall I? Okay, my screen is visible now?
Yes, ma'am. Yes, ma'am.
Yes. First query is about, in rare case scenarios, is it mandatory to have full sample size? And one person I asked, I think he is from Nepal, due to COVID situation, I could not get the required sample size proposed in my protocol. What can be done? Well, ma'am?
Yeah. First of all, what do you mean by rare case scenarios? Suppose if you are going to take a Ebola virus, it's a rare, the sample size cannot be achieved. And it depends on the rarity of your study. Okay. See, if you have taken a rare case scenario, for example, you think that in a month in your OP, it is going to be a 2 or a 3, three patients you will be hardly getting, and in a year you will be getting like a 12 or something like that. Due to COVID, we cannot get 12 also. In this case, what you can do is you need not think about your sample size, or if you are a PG student, my advice is that you can end the study by describing it, not finding out or exploring something, or it cannot be generalized to the whole population. So just you can describe the study and leave it and say it in a limitation. Since due to COVID, I could not complete my sample size, so I just describe, I am not testing anything like that. It depends on the topic and the rarity of the subject, so it needs a wider discussion. If you're willing to, you can write to the email ID and keep in touch with us. That is what I can say. Okay, rare. What do you mean by rare? That's my question to you. And if you're a PG student and you couldn't get the, just describe even 5 cases. You can describe and leave it. Don't generalize the results. That is what is my advice.
Thank you, ma'am.
The limitation column in the dissertation.
Thank you. That's what even I told them. You can put it in the limitation part. Then the next query is about, we have studied the presence or absence of 14 different complications for 3 different groups: children, adolescent, and adult. This is one of our consultant, ma'am. Actually, he is a fellow from Army. He has conducted the study. So there are 14 complications after cochlear implant, and studied in 3 different groups: children, adolescent, and adults. So if we put chi-square and SPSS, it gives the p-value separately for each complication among the 3 groups. That is, for example, electrode extrusion is one of the complication. Device failure is one of the complication. It is saying like in chi-square, electrode extrusion, the p-value between 3 groups is significant. But in device failure, the p-value is not significant. That's how it is coming in SPSS. Whereas in our group, if we put if we put compiled all the 14 complications for 3 groups, and if we categorize like electrode extrusion, 2 people in children, 1 people in one person in adolescent, and 1 in adult. The same way, device failure, we have 14 in children, 15 in adult, 12 in adolescent. So if we group it, and if we put it in our software, it has only maximum 10 rows can be entered. 14 rows could not be entered. So he is asking how to find the collective statistical difference, not an individual, each complication separately individual difference. We have to find out a collective difference, whether the complications are more in children, complications are more in adolescents, or more in adults. That's how he wants the result. What to do for this, ma'am?
Whether clinically these 3 groups will have in common, or some of the complication will be common for specific groups. That also you need to think. Our software maximum only 10 rows. The built-in application, say already the program which is available might be for 10 rows. If you could see the syntax, you can correct it for any number of rows, because the already existing syntax might be for 10 rows. If you could call for a syntax of that particular, you can have more than that. And also, see, if we need a collective statistical difference among 3 groups, you can go for a Kruskal values test instead of chi-square test. Kruskal values test, or you can also do a Friedman ANOVA. See, in Kruskal values test, if you are going to do this, it is for a categorical test wherein you can, for all the complications, you can, if it is applicable, you can rank the complication. This is predominant and the next predominant, like that you can rank and do the Kruskal values test. And between the groups, you can go for a Mann-Whitney test, like children with adolescent and adolescent with the adults. You can go for a Mann-Whitney test. That is the best possible thing we can do, since it is both are a categorical variable. The complications can be ranked if you know already these complications are predominant, or if not, also if you could find that out of 14 complications, all the 3 groups predominantly have a particular complication, you yourself rank for your research and say this is the way we have ranked, and you can do a Kruskal values test.
Okay.
And also you can report the median complications or a mode complication, number of complications, the highest frequency which you are having, that is a mode.
Fine. Thank you.
Yes.
And in a study where we enlist the complications encountered during surgery, and we don't have a comparison group. I think this is from a radiology PG, not radiology, sorry, this is from ENT only. during surgery, they have done surgical complications that has been enlisted, and they don't have any comparison. I think cholesteatoma surgery, during surgery, they have a few complications, 1 to 5 complications. Is it mandated to use a statistical analysis, or just a percentage and proportion is enough?
My advice is percentage is enough. See, if you put a more advanced statistics or any statistical tool only, you can prove it is not like that. You can have the result as a percentages or proportion. But my additional advice to that percentage or a proportion which you are calculating, try to calculate the confidence interval for the obtained proportion. For example, if you are going to have prevalence of a complication encountered during surgery, and you will be putting that in a proportion, just calculate the confidence interval for that proportion. There are so many calculators available in the net wherein we can calculate the proportion confidence interval, or you could approach any of the statistician, they will calculate and give. So what do you mean is that the proportion which you have obtained is for your study. If somebody is going to repeat the study, or if you are going to generalize to the whole population, that will fall in an interval that is called as confidence interval. Okay, so that way you can generalize that. If it is a wider interval, generalizability is questionable. If it is a narrow interval, yeah, very well you can generalize that without a p-value.
Thank you. And this is a general surgery thesis. I need to find the risk association of a preoperative clinical finding. That means pain, fever, vomiting, headache, visual disturbances, etc. That were preoperatively, these clinical findings were enlisted and correlated with the intraoperative findings. That is, they are doing some surgery, and during the surgery, the intraoperative findings, that is duration of surgery, that is graded as less than 1 hour and more than 1 hour. Blood loss, some less than 50 ml, more than 50 ml. Adhesions, ease of dissection, adhesions present, absent, ease of dissection, easy, difficult. Complete removal, complete or incomplete. That's how they are grading it. And they are finding the risk association with the preoperative clinical findings. Pain present or absent, fever present or absent, vomiting present or absent. That's the way they have put. Do I have to put odds ratio and relative risk separately for all the findings? Or do I have any other method to compare everything together? That's what their question.
Ma'am, whether they have a control in this?
No, they don't have any control, ma'am. They have only one group. That group, they are checking taking their preoperative pain, fever, vomiting, all those history, their preoperative data, and they are doing surgery for that group. And during surgery, they are measuring certain measurements. Then they are finding if a patient is having pain, means if the duration of surgery is more or not. A patient having fever, the duration.
Ma'am, most of the time, am I audible?
Or everything. Yes.
Yeah. Most of the time, the odds ratio relative risk will be put only when we have controls. Okay, controls. If you are doing a case control study or some operative procedures, different operative procedures for two groups, in that case, we can give a odds ratio and relative risk. See, for example, for together separately for all the findings, you can give a odds ratio with the help of a 2x2 table, and also you can have a regression like multivariate analysis and odds ratio for each of these things. But definitely you need to consider about your dependent variable. For example, at the start of my career, people used to come and they were asking for odds ratio. Then I immediately asked, which is your dependent variable? See, the person who was doing the study was doing among the stuttering. Why the stuttering happens? The people who stutter, okay, stuttering mouth they have. they wanted to find a odds ratio with so many inputs, but only she has taken the sluttering children and she asked for me a risk ratio. Since it's a start of a career, what I thought, I just explained, ma'am, I need to have a thing present and absent kind of thing so that I can find out the odds ratio by applying my statistics. So immediately, she is also not from a medical background. She is from a genetics. So she is doing a MSc genetics, and she would immediately post, ma'am, I have data with this consanguineous and non-consanguineous. With that, we can find a odds ratio. Yeah. Even I lack a medical background and she lacks a medical background. We did a wonderful regression tool and we found out odds ratio and we have sent to the publication. The publication caught hold of us. Okay. Yes, nicely reviewed because we did this study with 70,000 people. So he really appreciated our hard work, but definitely he gave a comment. Consanguinity is one of the risks for having sluttering mouth. So don't p-fish your data. That is the word I got, p-fisher. Just because I wanted to give a p-value and odds ratio, I should not have my dependent variable in a different angle. So consider what is your dependent variable and then do a clinically meaningful odds ratio. If it is not applicable, leave it. Don't give. You just give a percentage and a confidence interval. That's it. Don't p-fish your data, or just because for giving odds ratio, don't do that. If it is not a case controlled backup, don't do that. That is my advice at the start of the career. And the review is so good and he appreciated our hard work and he gave the idea. So while doing odds ratio, think whether it is a dependent or outcome variable. Really it is, okay, as in the case of sluttering mouth. Thank you. I think I have clarified some.
Yes. This is our last question. This is the question from Dr. Vijay. OSA prevalence in India, multicentric study. How to conduct a multicentric study, how to estimate the sample size. Is ethical clearance needed from all centers? And how many authors can be included? Any other specific concerns? This is the last question.
See, if suppose you want a sleep apnea prevalence in India, you can definitely do a multicentric study. How to conduct? If you have if you are going to have data who are all have sleep apnea among the participants, normally we don't have a list who's having the problem. So what we can do, we can go by a cluster sampling method as a multicentric study. Okay, then you need to calculate the sample size based upon the cluster sampling technique and the available evidence from the literature. The sample size estimation. Since it is a prevalence study, there is a simple formula, but we need to go by a cluster sampling. We cannot go by a simple random sampling since it's a multicentric sampling. And is ethical clearance needed for all centers? Many a time, definitely it is not. The center, if the center requires, if the center asks for, we need to present it for ethical committee. For example, we are from the university and we are doing an institutional like 3 institutes under our university are there, and I'm going to do the study. Already University Ethical Committee has approved that, but each institution, since it is a health setup backup, they requested the students to again present it in their ethical committee because they are the end users, they are the those who are dealing with the patients. So definitely we need to obey. So in that you need to think what is the need for that multi-center to ask you for an ethical clearance. So you can understand it better because how far it is important. They should not simply ask, there should be some reasonable thing to ask. So while planning multi-centric study, in each of the center, you recruit somebody who can monitor your study. That will be having a good result. So each of the monitors can present to the ethical board. How many authors can be included? If it is a multicentric study, I have seen a paper, there are 40 authors also. Okay. Whenever we have a vaccination study, you go and refer. So many clinical trials are there with 40 authors or 25 authors, wherein everyone, each and everyone, even in some cases, the credibility is given to the participant, study participant. So it depends. It depends on the contribution of the authors to the study. If it is a multi-centric study, each of the monitors have the observers or monitors have their role to play. So you can give to everyone. So you based upon the thing. See, one more point I have to. Only NCI says author, co-author, corresponding author, all those stuff. But if you go to the editor or a publisher, for him all are authors only. Okay, so you decide who can be given authors. You can include so many. Nobody can question. Each author has some contribution towards the research. That is the publication ethics. Okay. And also, Vijay, I would like to pose one question. See, how many authors can be included? Many times statisticians are not given place in the authorship. They think that we put into the software and we are giving out the output. So why it should be given? So for this audience, I definitely tell there are roles to play. A number garbage in, a garbage can be out. We used to see the data in a different angle. Definitely, if you feel that a statistician has given some inputs to you, then see, if you're going to put an independent t-test and I will put and give, then don't give authors. If I say that this data definitely cannot be used for independent t-test and I give some inputs or some ideas to that time definitely people can include as an author. So many times that will work out also. If a statistician in the study is been included, it is a valid for your study. That's what my concern. Not being a statistician, I'm telling there are some good inputs are given, so you can consider them for author. Yes, any concerns? That is what I'm telling. A statistician or epidemiologist can be a contributor as being contributor. They can given as an author.
Sure, ma'am. Sure.
Vijay is going to do the study. Definitely, I have given now itself so many ideas. So he can give authorship to me also. Thank you. Just for a joke, just for a fun, I have joked.
No problem.
Yeah.
Now I'll stop sharing. Vijay?
Yeah.
Vijay? We can share the questions. We can discuss the questions and we can conclude. And okay.
Yeah. Almost six questions.
Yeah, actually, I have one question, I think. No, ma'am, you can finish first.
Shall I start the answering?
Yes, ma'am. Yes, ma'am. You can start.
Yeah. The first question from the audience side is, how do we calculate confidence interval for a certain study? The difference value is absolute. So we can we mention the range of confidence interval? Please clarify. See, confidence interval you can always give for the whenever you are doing a study. This confidence interval, what does it tell? In your study, you got a value when in the when I generalize, it may vary from this lower interval to the upper interval. See, the calculating, how we can calculate confidence interval is nothing but if you're doing a proportion study or a mean study, the measure plus or minus 1.96. If it is a confidence interval, 95% confidence interval, the table value for 95% confidence interval is 1.96 into the standard deviation of the measure should be done. So the formula for confidence interval is nothing but measure plus or minus 1.96, that is the table value of 95% confidence interval into standard deviation of the measure. Okay, why I'm telling measure, it might be the measure might be a percentage or might be a mean. And the next question, what different information do the p-value and confidence interval tell? See, this p-value and confidence interval are inversely proportional. If suppose I keep 95% confidence interval, I will be seeing a p-value less than 0.05, that is 5%. Okay, this p-value tells only us whether to reject whether there is evidence for my research or there is no evidence for my research. But this confidence interval tells me the value obtained from my study and how it varies in the real world scenario. For example, if you are finding a prevalence of hypertension among school going children is 21%, and the confidence interval is going to give as 15 to 25, then it is the message that the children might vary in their prevalence in the real world from 15 to 25. Also, this p-value significance is no more an evidence for journal articles. If you are going to give a p-value, anybody can give a p-value. Just saying that p is less than 0.05, I can put p equal to 0.006. But when I give my confidence interval, it really tells the significance and supports my p-value. As I said, in the confidence interval, if it does not contain 0 in my study, then it supports my p-value or is significant. Okay, because the publishers are interested to make more evident publishing. So definitely, if p-value is cooked up, confidence interval can caught hold of it. That is the thing. Since we are using the two measures, mean, standard deviation, like proportion and the standard error of the proportion. So that is the difference. And for a true research, give both p-value as well as the confidence interval. I have missed out. So the audience has asked when to use one-tailed and two-tailed test. Kindly clarify in a simple words with possible example. For example, I am going to...
Can I answer the question?
The question is when to use one-tailed... Yeah.
With TNT example, can I clarify this question, ma'am?
Yeah, sure.
I think most of the audience will be ENT. If we are doing a cochlear implant and if we are doing a stepidotomy, in stepidotomy, we have the output can be either the hearing will be improved or the hearing can deteriorate. There are two options. After doing the surgery, we have either the chances of getting hearing improvement may be there, or the chances of getting hearing deterioration is also there. So in this, we are taking a paired sample. Like pre-operatively, their audiogram will be taken. Post-operatively, their audiogram will be taken, and we will compare using a paired t-test. So in this group is an example of using a two-tailed, because the output can be either improvement or deterioration. Whereas in cochlear implant, already the patient is having a profound hearing loss. So there is no chance of further deterioration. So the output is only after surgery or how much is the improvement that they are getting. So only improvement. So the one here we have to choose one-tailed. That is my understanding regarding one-tail and two-tail. Am I correct, ma'am?
Yes, ma'am. Yes, exactly.
So, and I think Vanilla can take the rest 3 questions now, ma'am.
Yeah. And one more thing, ma'am, if they very well know that there is no possibility of deterioration or like that, they can go for a one-tail test. Otherwise, no, simply they go for a two-tail test, and whatever the results coming in, we can accordingly, whether it is improving or deteriorating, that can be discussed. If initially, if you have taken improvement and there is no improvement, at the end of the research discussion will be difficult. So in a health setup, normally we take two-tail test.
Two-tail, that will be better. Yes, ma'am. Vanilla, rest 3 questions for you. Vanilla?
Sorry. Without unmuting, yes, sorry. So one person have asked about, I don't have a statistician with me. I don't know how to use SPSS data, etc. How do I go about statistical calculations? Any acceptable resource on internet which journals accept? Actually, for this, you can download free statistical analysis software like EpiInfo, which is one such software. And you can also try to use Jamovi. It's a free software again, or else InVivoStat. Okay, all these three are trusted software, and you can do the analysis in this software. And if you have used any of this software, and you can write in the analysis part, like whatever software you used, like whether it's EpiInfo, you need to put the version of it, and you can send it to the journal. They will accept for sure. Okay, so these are the few statistical softwares which they really accept. Okay, other than this IBM SPS, most of the statisticians have SPSS, or those who working in organization, they can be having or SPSS and all. But since it's a licensed software, and which cost around so many lakhs, and you can download this free software also. You can work on this. Once again, I repeat the software name: EpiInfo or Jamovi or InVivoStat. You can use any of this. Okay. And next question is
Sorry,
regarding.
Vanilla,
Yeah,
sorry.
yes, ma'am. Yes, ma'am. Sure. Please add in.
See, you can have so many open sources software, and you can download. As I said, whatever you are going to give in, it is going to let it out. So
Yes.
strongly about the statistical objective and statistical knowledge about the particular test, then go for the open source software. Otherwise, kindly a statistician or epidemiologist for your analysis. So keep in mind, it is a machine. So whatever we put in, it is going to give a something. So even if you have a correlation for ID number and the weight, it will definitely give a correlation. So you should know how logically, how clinically we need to think about and put that in the test. So don't simply that without knowing that.
Yes, ma'am. Very well said. We should have that logic behind what we are using and what we are applying. Yes, ma'am. What you've said is very, very much right. If you know the concept and the theory behind it, okay, you should know your data is parametric or non-parametric. You should know what the criteria should be met before doing ANOVA. There are so many assumptions for each and every test. Okay, when dealing with the parametric test, once you know for sure all this, then only you can work with any software. Or else, simply as ma'am said, whatever you are going to try to get, it is going to give you. You only should know whether it is meaningful or not. Okay, so moving to the next question. Regarding EpiInfo, one person have asked, like, you said bugs fixation and update keep on coming frequently. How do I make sure my data will not get corrupted? Then the whole exercise is a waste. Is it reliable platform? See, actually, the bugs was keep on coming when they were dealing with classic mode only. Okay, now after once the visual dashboard version has been launched in EpiInfo, the scenarios of bugs have been have reduced so much, and it does not affect your data at all, because I have been using EpiInfo for the last 3 years, and it will not affect your data for sure. It will not get corrupted. Okay, it is being saved, and if at all you have the bug also, it will not affect your analysis part. Okay. So you can trust EpiInfo, since it was developed by CTC and WHO together, and it is a very much trusted one. So you can go ahead. So do not worry about that. And the next question is, what advantage is this EpiInfo giving over Excel? This looks so complicated and non-engaging and non-user friendly. What is a message? Okay, I sincerely advise the person who have asked this question to download EpiInfo and see it for yourself. Okay, since this similarly the same way only I thought when someone was giving EpiInfo demonstration to us. Okay, but the one thing is, it was a live demo, so we also have been asked to install the software, and we have been we was doing step by step whatever they were telling. So once I started doing, I realized how easy it is. Okay, so I strongly advise you to download the software and go to the manual and see it for yourself. Whatever steps you have been asked to do, kindly start doing it, and just seeing will look like this only. It might look very complicated and non-user friendly, but if you if you start working on epi info, you will feel very easy, very user friendly. So you download and first download it and check it for yourself.
One more point I would like to add upon, Vanilla.
Yes, ma'am.
Epi Info is an open source software, and you can minimize your errors in typing, as Vanilla said. And also you can save the project in their project file, which is automatically saved in the server of the Epi Info. So you need not worry about the data. And see, as in this user-friendly software like SPSS, most of them are using pirated version. So later pirated version definitely corrupt your hard disk. So be cautious while downloading your, before 17, SPSS 17, the pirated version does not disturb your hard disk. But after that, if you are going to load it, definitely the machine gets corrupt, your system or a laptop, the hard disk totally corrupts if you are using a pirated version of IBM SPSS statistics. So be cautious with that. And also, whenever we are publishing, they will ask the software. When I quote Epi Info, there is no questions. When you quote SPSS, the license version, whom do the license belong, everything is there. So future is not going to be so easy as we use pirated software. So use Epi Info software, or go to a statistician who is having institution-based SPSS software or some other software which is really helpful. Okay.
Yes, ma'am. I have one more point I want to add regarding the last question. They asked about the advantage over Excel. So the advantage for Excel is like in Excel only we can enter the data, but the statistical analysis cannot be done in Excel. Whereas with Epi Info, with the same entry, you can do the, if you go to the analysis part, you can do the analysis. No. So that is also, we did not import it separately, because when a PG is entering their data in Excel sheet and they're giving to statistician, the data cleaning process itself is a big process before entering into the software. See, the software takes only less than 5 minutes to calculate and give the chi-square value or whatever part test value. But before entering into the software, we have to clean the data that is given in the Excel. That takes much more time. But when we enter in Epi Info, it will automatically we can do the calculation. No, so that's what my inference.
Yes, ma'am. Yes, ma'am.
And the next question is about plagiarism. They've asked. Actually, we were thinking of showing a live, like Vanilla, what she had done. No, how to do plagiarism check. But due to poor net connectivity, I couldn't do that. So, how to check plagiarism? Before submitting the article for a journal, is there any software available? Yes, we have software. Urkund is a good software for plagiarism, and Turnitin is also a good software, but that has to be purchased. Grammarly can also be used, but Grammarly mainly checks the grammar than the plagiarism. We have to upload the full article. It will check the word count, and it will check the matching with which previously submitted article, this portion, which portion of our article is matching. That will be highlighted red in that. And we have to change that portion. So this portion, like introduction, this paragraph shows 100% plagiarism. This paragraph, like if when you use some definition, no, it will show us 100% plagiarism. So we have to put it in an inverted comma. We have to say it as a definition. And some any other thing, that percentage of matching, that will be shown, and we have to change that specific thing. It will be marked in red. And those part which is not showing plagiarism, that means that we did not correct anything in that. And finally, the plagiarism percentage, many journals accept a percentage less than 15%. So even the thesis also, the percentage of less than 15% will be acceptable. So we have to upload it in the software. But actually, there are some free softwares available. There, what they will use, no, 100 will be the word count. Sorry, 1,000 will be the letter count that is acceptable. Word count that is acceptable. So 1,000 words is the maximum limit that you can upload and check the plagiarism. So 1,000 word limit, we can't finish an article. So we have to check part by part. There, it won't be complete. Like one part will show major plagiarism, the other part will be less because observation result part will get less plagiarism. So the total plagiarism count we can't get by adding and dividing by 3. We can't get. If you are uploading 3 times and 3 times you are getting some different plagiarism, and if you are adding those 3 values and dividing by 3, that percentage will not give your exact plagiarism value. So better to get it done in an appropriate software, which will enable you to put the whole thesis or whole article in one shot, and will get the plagiarism count in one shot. Any other point regarding this, ma'am? Vijay? Vijay? You can share the question screen and we can discuss that and we can conclude this. Valar ma'am? Yeah. Valar ma'am?
No. See, what is the ideal statistics test for comparing a numerical paired data for more than 2 groups? See, here there are 2 groups, more than 2 groups, and you want a paired data. If it is more than 2 groups,
The screen sharing is not there.
Yeah, for more than 2 groups numerical paired data, you can go for a repeated measures ANOVA. So simultaneously, we will be taking ma'am, this question is a little bit tricky, I think. More than 2 groups, okay, and a paired data. Okay, if you are going to compare,
the question.
In between the groups we are comparing, multiple times we take the data. If we are taking multiple times the data, then we can go for a repeated measures ANOVA. If it is even 2 groups and you are going to have paired data, then also you can go for a repeated measures ANOVA.
Yes, ma'am. Like for example, in our study also, we have taken a baseline data. We have taken a data like cochlear implant is beneficial to hypoplastic nerve. We have taken a baseline data. We have taken a data at 6 months interval, and we have taken a data at 1 year interval for the same group, like pre-operative, post-operative 6 months, post-operative 1 year. So this we can go for a repeated measures ANOVA.
Yeah.
Next question, ma'am.
Yeah, what is the test used for categorical data if sample size is low? See, sample size doesn't decide. Okay, if it is less than 20, you can go for a chi-square test. And also you need to have what is your objective? The objective and Fisher exact test, if the cell is less than, if the cell means where a row and a column meets, it is called as a cell. And if it is less than 5, definitely we will be going for a Fisher exact test.
Yes,
when smaller groups of categorical data is tested, the best way is to have cross tabulation and do a Fisher exact test or a chi-square test. All the following are used when the numerical data is not in normal distribution except. All the following are used when the numerical data is not normal except.
I think this is Fisher exact, no, ma'am?
Yeah.
Because other all are numerical. Yeah.
Yes. Numerical and if it is not normal. Yeah. Fisher exact test. Mostly Fisher exact test we will have a smaller comparison. Yes. And value of R is plus Moderate positive correlation, value of our fourth question.
Yes.
Then
Fifth,
next
Vijay?
question. Yes, is denoted by usually row value, RHO or row value. Okay,
Yes.
row value. And it's called
Vanilla
Spearman's row only. Spearman's row correlation only. We will call it. Yeah, Vanilla.
Yes, ma'am. So here is the question is, what is data management? So I hope after today's detailed session, you can able to tell the answer is all of the above. Okay. So here data management deals with all of this, creating your questionnaire in the software and how you collect the data, how you enter the data, how you validate the data, and the coding. So all this is about data management. So next question is actually all of this data management question will be very simple, okay? Because so I think you can understand it. So with EpiInfo you can perform the following. So it can perform all of the above. Okay, so the answer is E, all of the above. It can with this you can form an electronic questionnaire form. We can enter the data and analyze it and create report and maps, as I told you. So the next question is, which of the following is not a statistical analysis software? So here today we have discussed about EpiInfo. So EpiInfo is one of the software, statistical software, and SPSS is IBM SPSS is very well used statistical software. It's a paid software, licensed one, and R is again a free software, freeware, like just like EpiInfo or software. So the last one, P option, G power. So this is mainly used for calculating sample size. Okay, G power software. So the next question is, in Microsoft Excel, you can perform the following. You can perform all the first three. So the answer is all of the above. Data, you can manage the data, you can analyze the data, you can do the data reporting. But only thing is, it will take lots of time. It will, you can, chances of errors are there while dealing with Excel. So only we are advising to use the software. Either you go to the statistician or you learn the, at least learn the manuals about the free software and start doing it in softwares. Okay. So the next question is, other than statistical analysis, EpiInfo can perform the following functions. Okay. So today, when I told about EpiInfo, you understood that EpiInfo can be used for a data collection, mainly a data collection. It's very easy for data collection, and word processing and GIS mapping. This is when you do this ecological study, this geographical studies and all, you can use that map in the EpiInfo and you can use that also. So here is the answer is C, both A and B is the answer for this question.
Thank you. Mine is, if the research results were generated by manipulating the data, it is called falsification. Yeah, because fabrication is if the study is totally not done and for totally cooked up, it is fabrication. In this, we are manipulating the data to obtain a result which we intend to get. That means that is falsification. That will be the answer. What does COI stands for? That is conflict of interest. That is COI. The next is, which of the following one is the checklist for submitting an article? Is TROBE, that is the checklist. The evidence-based medicine includes all except the clinical expertise is there, best research evidence is there, patient values are there, but a doctor's choice is not there in the evidence-based medicine. And measure of frequency with which the article with which the average article in a journal has been cited in a particular year is called impact factor. So that's it. And I think this winds our whole session. I thank Valarmati ma'am, Vanilla ma'am, and Premlata ma'am for their time. And I sincerely thank Professor Mohan Commissioner sir for this opportunity, and Dr. Vijay, IAOHNS Secretary, for this opportunity. Hope we have done good justice for our time and for the topics that we have handled. Thank you.
Thank you, ma'am. Thank you for inviting us here to this platform and give our sessions. Thank you.
Thank you very much. I would like to place my sincere thanks to all the speakers and the participants. I think this time also more than 250 participants have participated and raised a lot of questions and interest on this particular topic. And this program is also going live in YouTube and Facebook by the side. Thank you very much, everyone. And I have uploaded the link for filling up the member participants who wanted Tamil Nadu Medical Council credit point. Please fill it up. So once the Tamil Nadu Medical Council approves whoever attended all 3 sessions will be sent a separate mail regarding the payment of rupees 100. So once you pay that 100 rupees, you will be getting the credit points. Thank you once again.
The credit points will be added to their account directly by the TNMC, Tamil Nadu Medical Council.
Then we conclude this session. Thank you, one and all.
And one more thing, as Professor Mount Commissioner sir said, the audio was not clear regarding that. Vijay, can you put a word about that also?
From Indian Academy, we are planning to start the research committee where all the researchers and postgraduates can post their questions and queries from the beginning of their research work, from starting the title and how to make the proposal. Everything can be aided, helped by the Indian Academy. So those who are willing to get the information from the team can send a mail to IAOHNS@gmail.com. All the details will be available in the website soon. So this research committee will help you to bring out your thesis and help you to publish in the well-reputed journal.